go. Hey, everybody. Today we're debating flat Earth versus globe Earth, and we are starting right now with the globe Earth side. Thanks for being with us. Dr. Blitz, the floor is all yours.
Hi, so I'm Blitz, and I'm getting over a cold, so my voice sounds like this. I have a doctorate in mathematical physics. And while Peter is going to address perhaps the most damning and obvious piece of evidence against the flat Earth, the sun, I'm going to take another approach. I'm going to show that believing the flat Earth claim seriously comes at a wickedly high price, one that I don't think anyone here or in the audience should take. So believing the flat Earth is fundamentally anti-scientific, despite what, flat earthers will tell you, right? But believing the Earth is flat, rather by believing that the Earth is flat, you have to believe a series of other increasingly unlikely positions. These are things that directly contradict essentially the entirety of modern physics for the last 300 years. So as a prime example, a flat earther has to discount the existence of mass attracting mass, what we call gravity. And the reason they have to do that is because we all know that if gravity exists, it would pull any sufficiently large mass, like a planar Earth, into a spherical shape. This rejection of gravity means a rejection of Einstein's general relativity, of course. And note that this claim is absurd on its face, because general relativity can be and has been tested locally on Earth in laboratories. Indeed, even early experiments were able to establish a high degree of agreement between theory and observations. As far back as 1964, experiments were devised to measure the effects of gravitational redshift as predicted by Einstein, with results agreeing with the model at the 99% accuracy level. Rather, flat earthers will often say something like gravity is electrostatics or it's density, which isn't a force, by the way. And while it is true that electromagnetism is stronger than gravity, the claim that electrostatics can account for the forces observed flies in the face of everything we know about electromagnetism, and that's the force that we know the best. Notably, neutral solid metals do not extend outwards electric fields, and they hence don't produce electrostatic forces on other objects. And it's fairly easy to tell when a metal is electrically neutral. Alternatively, a flat earther might claim that its density, which I should remind everybody is just a number, it's mass divided by volume, they'll say that it explains why objects fall, but they can never account for why, say, two large lead spheres attract each other, nor why a quantity like density should imply any directional motion at all. When they do this, they're disagreeing with Newtonian physics that has been known about for over 300 years, the same physics that all of modern engineering relies on to work. A flat earther also has to reject the rotation of the Earth, as it implies a non-planar shape. Unfortunately, in doing so, a flat earther has to reject the Sagnac effect, which can conclusively determine whether the measuring device is in an inertial reference frame or not. Of course, when one uses a laser gyroscope, say, to perform these measurements, the experiment detects a positive result, namely that the interference pattern appears, demonstrating a non-inertial rotating reference frame. Of course, the original results of the Sagnac effect are consistent with both an ether model and special relativity, but neither are consistent with a non-rotating planar Earth. Certainly by rejecting the Sagnac effect, you have to reject special relativity. So to be clear, a flat earther has to reject Newtonian mechanics, special relativity, and general relativity in order to hold their worldview. So the question then is, who cares, right? Well, physics isn't done in a vacuum. It's built on a well-trodden path on the shoulders of giants, if you will. The audience might not know this, but the best scientific model ever produced, is a model in physics called quantum electrodynamics. And this model relies on special relativity, quantum mechanics, and classical electromagnetism, almost all of which a flat earther has to deny. And I can go into the details later, but suffice it to say, this model makes predictions that agree with measurements to roughly 1 part in a trillion. That would be 99.999 with like 10 nines after the decimal point percent. No other scientific theory even comes close to how accurate that model is. So to believe the Earth is flat is to reject special relativity and hence quantum electrodynamics, the single best piece of scientific achievement that humanity has to offer. To believe the Earth is flat is to reject Newtonian mechanics, the fundamental basis of literally all engineering. But, lest I be misunderstood, I'm not claiming with certainty that our understanding of gravity or quantum theory are perfect. Of course they're not. We drive science forward by improving our models and sometimes shifting the paradigm towards new, better understandings of the world around us. But bear in mind, when these paradigm shifts occur, old models are not thrown out and replaced with nothing. Rather, they're replaced by new models that can make even better predictions. And if that was what my opposition presented, this discussion wouldn't be happening on a YouTube channel. It'd be at a conference or in the halls of a university. But that's not what my opposition is going to do. They're going to present no alternative models with quantitative predictions. They're not going to do any statistical analysis, and they're not going to perform any rigorous scientific experiments. Only one of the sides on this argument can claim to have done all of those, and that's my side. So to my opposition and to the audience, is this really a price worth paying? In order to satisfy the belief in an undemonstrated flat Earth, want us to throw out effectively all knowledge of physics we have gained in the last 300 years. This means that bridges stand just by accident, not because Newtonian mechanics effectively describes the nature of force. That nuclear power used to power millions of homes works just by accident, not because of the merging of special relativity and quantum mechanics. That medical particle accelerators, which are used to treat certain kinds of cancer, work just by accident, not because we understand quantum field theory. And that GPS works just by accident, not because we understand general relativity and gravity. In my opinion, it's far more reasonable to accept the position that the Earth is a globe rotating about its axis than it is to accept that all of our understanding of modern physics is false and its applications are just happy accidents. So to my flat Earth friends here, the burden of proof is high and it's on you. Can you reconcile the centuries of experimental evidence demonstrating the existence of gravity and the rotation of the world we live on with a flat Earth? Or do you throw that evidence away in favor of, it looks flat to me?
Peter, we'll kick it over to you. Thanks for being with us as well. This is the second half of the Globe Earth opening. Thanks very much, Peter.
All right. Trying to share my screen here. Is this working? You guys see my presentation here?
Crystal clear.
All right. And if I full screen it, do you still see that?
Even better.
All right. Perfect. I will just go then. Nowadays there's a lot of confusion about flat Earth because flat earthers thrive on this confusion. They don't even want to acknowledge it, let alone correct it. So to clarify, I had to step in and coin a new term, robothymism. Put simply, robothymism is the belief that when the sun sets, it's going away instead of down. This might not seem that important at first, but I promise it is, so I'm going to say it again. I define robothymism roughly as the belief that when the sun sets, it's going away instead of down. You see, while most ancient cultures believed in a flat Earth, it turns out they still had eyes and brains. They could plainly see that when the sun sets, it goes below the horizon, so their cosmologies had universal nighttime and universal daytime. Today, we know the sun is always up somewhere. So nowadays, the idea of a flat Earth can only exist by adapting. That started with this guy, Samuel Burley Robotham. In his 1865 book, he wrote, "Although the sun is at all times above and parallel to the Earth's surface, he appears to sink below the horizon. This arises from a simple and everywhere visible law of perspective." Robotham's idea here was brand new. And yes, I checked. If you've seen this flat Earth meme, it's pure misinformation. No ancient culture in history ever believed the sun set by going away instead of down. Just Robotham. Thus, Robotham became the father of flurfspective. Just look at this diagram. To make it work, he had to put a big hill right in front of the observer. And also crop the diagram because these two lines are parallel and will never converge. A flat and level surface that's under your feet cannot block your line of sight to something that's over your head. Even my 6-year-old niece understands that. Sunset is quite literally as plain as day, and modern flat earthers are sunset deniers. I have never met one that isn't. To explain it, they use an absurd variety of rescuing devices. A rescuing device is something that has no positive evidence and contradicts previous claims or evidence. I am sure we'll see some rescuing devices today. But before we do, let's use this moment for some actual science. Through any 2 points, you can draw either a straight line or a curve. To fully disambiguate, you need at least 3 points. The more the merrier. Some examples. Eratosthenes' experiment used 2 points, but measured from a third and flat Earth is shattered. Elevation angles to stars correlate with latitude. 3 or more latitudes will destroy flat Earth. Similar concept here with arc length of longitude from Where's Wally using 1,300 data points. But you need at least 3, which usually requires traveling and or getting help from other people. Robothymism exploits this by isolating you, but you can still get 3 points by varying time instead of location, and that's precisely what I did. Here's a real diagram of how perspective works, not like Robotham's. With simple trigonometry, we see a Robothymist sun would follow an arctangent function through time. I demonstrated this visually by holding a flashlight at my waist and walking straight away from the camera until it was gone. If we overlay frames at a constant interval, we see the distance between images shrinks dramatically, then sits still for a long time before it's gone. But this is not what the sun does, and I took a 3-hour time lapse to prove it. If you're trying to measure the sun's size, exposure is a problem. To show this, I had two identical cameras side by side, one with welding glass and one without. But size was not the main thing I was trying to measure. It was position. I used a compass and sextant to get hard numbers, but the footage speaks for itself. When we overlay frames from the time lapse, when we overlay frames like we did with the flashlight, it's completely different. The distance between images stays the same the whole time. It just goes plops straight down into the horizon below eye level. Now pair that with the principle of time zones. UTC is 4 hours ahead of me, should be 5, but for daylight savings time. We all agree, I hope, that if I had done this experiment, this exact experiment, 800 miles east, it would have given identical results but an hour earlier. That means that at all times, for someone somewhere on Earth, the sun is currently going below their eye level. It cannot be both above and below a flat Earth at the same time. The only answer is that eye level is relative, changing by 1 degree every 69 miles. As assuredly as 1 + 1 = 2, sunset plus time zone equals globe. So, Tacori and Matthew, my challenge to you is simple. I measured the sunset and proved it goes beneath us. If you disagree, then explain where I went wrong. Show the math, show the missing factor, show a scientific theory, not a rescuing device, that explains my evidence. Thank you.
Thank you very much for that opening. We're going to kick it over to the flat side. Thank you very much for that opening as well. We're going to kick it over to the flat earth side as well for their opening statements. But do want to say, folks, if it's your first time here at Modern Day Debate, I'm your host, Dr. James Coons. Don't forget to hit that subscribe button as we have many more upcoming debates. You don't want to miss out on those. Hit subscribe right now. We're going to kick it over to Matthew and to Corey. Thanks for being with us. The floor is all yours for your opening for the flat earth position.
Okay, you want to go first, Tacori?
You could go first.
Okay, thank you very much. Okay, so to begin with, I always want to give thanks to the creator of heaven and earth at the beginning of every one of these, and to the Messiah. And I want to thank James Coons of Modern Day Debate for having me here, and it's cool to finally meet you. And I feel like this is a high quality debate platform. I do not think this is an inferior place to debate whether the earth is a globe or flat. So we could talk about that. But what I want to get to is I have a video. I asked Tacori to play a video of mine because I'm on my cell phone right now and I can't go back and forth on it. So what Globers always say in their during the debates, they always say, "Oh, the flat earthers didn't bring any evidence," which it's always not true. But I wanted to bring some definitive evidence of the flat earth to show you, okay? So Tacori, could you please what I would like to do, James, could you put Tacori's screen up, please? So he could put a video for me?
I got you.
You got it. Ready for you, Tacori. Folks, while we're waiting, if you haven't yet, please do hit that like button. We appreciate all your support, including those likes. It means a lot to me personally as well. Tacori, we're ready for you.
Yeah, so the story behind this, I went up to the hills of Fullerton.
Got it?
And you got it? Yeah, I'd say just play it whenever it's ready to go.
It's
Yeah, and I
almost
record.
ready. It's still loading. And then just a friendly reminder that we can't play audio from other channels. We can play video,
Oh,
but
the
it
other
just
one.
has to
Yeah,
not
the
have
other
the
one.
audio.
That's one of my demonstration videos. But could you play the one Southern California is flat?
We'll give Tacori a
Looks like
chance to find that video called Southern California is Flat. In the meantime, I want to say thanks so much for your likes. Just saw a big boost in the likes. Appreciate you guys watching live. Thanks for that. Or if you're watching later.
okay, that's the same one of my demonstration of a 90-degree sunrise on a flat Earth. That's a different issue we could talk about, but the opposition didn't bring it up. Maybe we could bring it up later, but in that one, I do demonstrate that a 90-degree sunrise on the equinox is possible for a multitude of people along one longitude line. But the other one I wanted to share is that video number 2.
Just to be,
And
just so we're on the same page, that no video has played yet, but I think you know that.
oh, it didn't work? Okay,
It
well,
was,
if there's a technical difficulty with it, anybody in the audience can go to my YouTube page, which should be linked in the description. And I have a video called Southern California is Flat. And I do a panoramic video left to right showing that there is no curvature visible. I appreciate it, Tacori, but if it's not going to work, it's cool, man. We could just click out of that if it's not going to work. I really appreciate that. And so because it's not working, guys, just go take a look at my YouTube page. It's my most recent video. It's a panoramic
Hey, you can't
video.
see it?
we
No, I'm
can
looking
see
at
it. It's just that I don't know if it's meant to be like this. It's that it plays so slowly. I
Oh
don't
yeah, I,
know.
I got some other stuff. I got my presentations up. That's why.
okay, hey, you could just click out. I'll just do a little bit of my
You want me
intro.
to go to
That's
the other
okay.
video?
Yeah, please go to the other video. Go to the one called Southern California is Flat so that people could see it. But if it doesn't work, the people in the audience could just go to my YouTube page. It's right there. It's a panoramic video of Southern California from up in the hills. It shows that it is flat. I watched it on my big screen TV at home, and I used a piece of yarn. I paused it, and I put a piece of yarn along the TV. It's perfectly flat. So that's evidence right there. Okay. Um, so, and then what Globers have told me, my really good friend, Craig, Provide the Flat Earth, he told me there should be 8 inches per mile square on this earth. And so, when I went up to the hills, I took my camera and did a panoramic view. The results of this experiment of determining if there was curvature on the earth, the result was that there was no curvature on the earth, which was very fascinating. So I encourage the viewers to go look at my YouTube page, which should be linked in the description, I think, and just see it for yourself. It's called Southern California is Flat. And then so what the idea is, you have to juxtapose these two cosmological models, the heliocentric model and the geocentric model. You have to take these two competing ideas and compare them with observable reality. Now, what we find is that flat Earth is based on observable reality, and globe Earth is a theory based on a theory which requires a theory which requires another theory. And it has gotten so bad. How bad is it at this point? Dark gravity, dark matter, dark curvature, right? And it's very interesting to kind of. I want to conclude my introduction. James, how much more time do I have left? Maybe like less than a minute, 30 seconds.
Correct.
Okay. Yeah, I just want to say perspective plays a huge role in how we perceive celestial phenomenon. That's the final part of my introduction. I want to say that our personal dome of observation modulates how we observe celestial phenomenon. So we're going to get into all that. I appreciate you guys. Thank you very much. And that's it.
You got it. We'll kick it over to Tacori. Thanks for being with us, Tacori. The floor is all yours for your 6 minutes as well.
Hey, I'm gonna show your video on my presentation if that's okay.
You got it.
All right. Okay, my name is Tacori Dawson. I've been here before. I debated the brother MC Toon, Michael Toon, on whether gravity exists. Okay, so now the topic of the debate is flat Earth versus globe Earth. My opponents, my bad. My opponents, they made a lot of claims, but they did not use no type of science. And we know that the definition of science is the systematic studying and the structure of our reality using scientific methods, using observations, repeated tests that can be repeated over and over again. These things that they have not done. So we're going to use observable facts. We're going to use mathematics. We're going to use angular perspective and calculate distance. All of these things that actually prove that the Earth is indeed flat, and that not only is the Earth not a sphere, but that the Earth is not in motion. So I'm gonna share my screen and I'm gonna get to my presentation. Okay, so now one of the things that we know. Hold on. Y'all see my screen?
It's still loading, so it's still on a black screen, but I think it'll be here in just a few more moments, ready for you. It's showing now.
Okay, so now these are different observable aspects of the sun. And as you can actually pay attention, if the Earth was curved or if there was curvature that was detected, that means we shouldn't even be able to see that whole mountain. That means that due to our perspective, everything is called vanishing points and converging points. Everything converges to the center because our eyes are spherical. It's not the fact that the Earth is spherical, but our eyes are spherical, so it converges at the center point, and then it disappears. If the Earth was a curve, then you should actually be able to see that. You shouldn't even be able to see none of that mountain because it will actually be curved downward. Okay, here's another one. Here's another one right here. Distance. Here's the distance of 167-mile distance. The observer height is 906 feet. Target hidden. Yeah, target hidden. My bad. Target hidden. Target hidden. Let me go down. Let me scroll.
And then just because it's cutting off the text on the bottom of the screen, it isn't full screen. You don't have to go full screen, but just so you know that
Okay,
we
target
can only
hidden is
see.
11,291 feet. Elevation of Monte Viso is 12,602 feet, meaning that there's over hundreds of miles of curvature that is actually missing. So they're gonna have to deal with that since they're talking about science and talking about observable facts. They're gonna have to explain where's the other missing 100 miles of curvature. Hey, so let's continue. Here's another one. Distance 68 miles. This is taking 68 miles. Observed for height 820 feet. Target hidden height 11,781 feet. Elevation of Monte Viso 12,602 feet, which is another 100 and something miles actually destroyed or actually missing from this curvature Earth. So that actually lets you know right there that y'all curvature calculations are off and that y'all curvature calculations are actually flawed. Now, there was an event that happened in 1963 with the Hyper X-15 hyperbolic jet. It actually flew at 67 miles up in the air. Now, this is from NASA. This is from y'all site. This is from y'all teachers that y'all love so much. Now, by the end of 1961, the X-15 has achieved the design of Mach 6, has achieved the access of 200,000 feet. Let me see if I can move this to the side real quick. Okay, 200,000 feet. In 1963 of August 22nd, Walker achieves the altitude record of pilot taking the X-15 of 354,000 feet or 67 miles up in the air. This was from Captain William J. Peet, who set a world record of the speed of 4,250 miles per hour, which is Mach 6. This is very important because on the globe that is 25,000 feet, that is 25,000 feet in circumference, is 67 miles up in the air. 67 miles to 25,000 feet is over one fraction of 371 degrees, or one fraction of 371. So which means that out of one, if you take a circle and cut it into 371 parts, which is very possible, that one out of 371 parts will be small. And your perspective will actually see the plane actually very small from above the Earth, which means due to their angular perspective, and if you actually calculate angular distance with the angular A or the angle A, which is 67 miles, that would give angle C, or the hypotenuse, a distance of a visual perspective distance of 67 miles. I mean 87 miles, my bad. And as you can see right here, here's a picture of the event right here. And they was 67 miles up in the air, and they was actually able to see the horizon, not only eye level, but it was also still flat. Now here's the actual perspective chart right here. You got one feet, which is 0.30 meters or 1.31 miles, or
1 minute left.
2.09 kilometers per distance. 1 mile up in the air would give you 96.1 miles in perspective. So every time you rise up 1 mile off the ground, you will have a perspective visual of 96.1. So when you multiply 96.1 times 67 miles, which is how high the plane was during the hyperbolic project in 1963, that means that this photo right here that they see, this horizon would be 6,448.8 miles, meaning that according to the globe earthers, they're saying that this person right here, if this person was flying up above the North Pole, he would be this right here would actually be the equator. But that ain't actually true, because if you rise up above the North Pole, it's
30
67
seconds.
miles up in the air. What'd you say?
30 seconds left.
Oh, my bad. 67 miles up in the air, you are actually, the angular perspective, if you calculate the perspective, will actually be 87 miles, which is meaning that there are over 6,380 something miles of curvature that is actually missing. So they're going to have to actually explain that. I'm done.
You got it. Thank you very much for that opening from the flat side as well. We are going to go into open dialogue section. So I want to say, folks, a couple of quick housekeeping things. First, thanks for being with us at Modern Day Debate. If you haven't yet, hit that. I've been muted this entire time. Sorry about that. A little bit rusty. But I want to say, folks, thanks for being with us. We are going to have a Q&A. So if you happen to have a question, submit your question in the old live chat. You can tag me with @ModernDayDebate. Otherwise, push your question to the top of the list by using a super chat. With that, gentlemen, thank you very much. The floor is all yours.
Who wants to start?
Well, one thing that stuck out to me was Tacori saying that we didn't present actual science, and I beg your pardon, Tacori, but what do you call what I showed? The experiment I literally did myself. I could show it on screen again if it would help.
And I can cite my sources for all of the claims that I made. I have citations in my notes if you want them, of like the actual peer-reviewed experiments that were conducted with data analysis and statistical models and things like that.
Well, I got some ideas about what you showed in the presentation. The path of the sun was curved. In the presentation we saw that actually had some type of material to work with rather than just opinions. It showed the path of the sun was curved in the sky. What are the implications of that?
The fact that it was not the equinox.
So the path of the sun in the sky is curved only
Yes.
on the equinox?
No, only on the equinox is it following an orthodrome. It was a small circle around the celestial sphere that time because it was not the equinox, which means it's going to look curved.
So do you agree or disagree that the path of the sun in the sky is curved?
If by curved you mean not an orthodrome, then yes, I agree. Since it was not the equinox, it was curved, yes.
Okay, so you just lost this debate. You just lost the debate because
Try not to play referee in your own debate, bud.
No, let me explain it. Because you just agreed that the sun makes a circular path in the sky. Thank you for playing.
It's a circle around the celestial sphere, not around the North Pole.
Modern day debate is where debaters come to die. So thank you for playing, Peter.
Okay, grow up, come back to the debate here, and
to be fair, hold on. To be fair,
you asked about the experiment, and I gave you my opinion.
if there is a light bulb on the ceiling and you move in a circle underneath it, it will also look like it's moving in a circle. That doesn't mean that the light bulb is actually moving in a circle, right?
That would mean my perspective would be changing as I move across the flat surface of my floor with my perspective focused on where that light is.
The point I'm making is that the apparent motion of something doesn't necessarily indicate the absolute motion of that thing, right?
But your teammate just agreed that the sun has a circular path through the sky, which indicates that the sun is moving, not the earth.
No, it just means that that's what it appears to be doing. Like you can draw a picture on a sheet of paper and it'll look like a circular path in some sense. That doesn't mean that it's actually moving.
Did you just say if I draw a circle it will look like a circle? Did you just tell me that?
No, I think you misunderstood. Regardless, the point is the appearance of something. Regardless, certainly you understand that when you are moving relative to something, it can appear as if other things are moving relative to you. Right.
Yeah, but
that's classical Galilean relativity.
But there will be other factors involved that you could determine whether or not something was moving or not.
How can you do that?
Like you want me to explain to you how you could determine if the earth was moving or if the sun was moving?
Yeah.
Well, we could do something very simple. Anything like you could notice that the earth is not moving. You could use your God-given senses, go outside.
From ignorance fallacy.
Excuse me, you didn't even let me finish.
Tell you how we know that the earth is not moving?
Please.
Okay, so have y'all heard of meridians?
Yes. Sure, those are the I never remember longitudes, latitudes. Yeah, longitudes, that's what it is.
Yeah. Okay, so now there's a flight path that took 5 hours and 59 minutes to get to, all the way from I think Russia all the way to Africa. It's on the meridian line. It took 5 hours and 59 minutes to get to. Now, mind you, that your Earth is turning at 1,000 miles an hour. It's like, yeah, it's 5 hours and 59 minutes. The Earth is supposed to be turning at 1,000 miles an hour to the east, right? Okay, so since it's turning at 1,000 miles an hour to the east, and it would take on that meridian line 5 hours and 59 minutes. That means that if you actually do cross proportion and cross multiplications, you will actually find that by the time you get to that location or where that location supposedly be, that area would have been turned 5,700 miles all the way to the east. So can you explain to me can you explain to me how could you get to your location in that particular location that is confirmed to take 5 hours and 59 minutes to get to if the Earth is spinning?
Are you forgetting that the airplane is moving relative to the Earth, not relative to some fixed point in space?
It can't be moving relative to the Earth because it's not on the Earth. So it's moving at its own speed.
The air is attached to the Earth gravitationally. It is moving through the air, which is bound to the Earth.
Yeah, hold on. That's where you
Additionally, just because the plane leaves the ground doesn't mean that the plane magically loses all of its momentum that it had while it was resting on the ground.
So hold on, wait a minute. Are you trying to tell me that the air can blow an airplane to right where it want to go to?
It's not blowing.
Hold on, so wait a minute. Let me get something straight.
Do you not understand relative motion?
And when I get from work, I wish the wind can blow me directly to my job. So you telling me that
understand relative motion?
Can get blown by wind?
Yeah, I'm pretty sure he doesn't understand relative motion.
That's fine. Galilean relativity is hard, and I understand that. Look, do you think that the air? Do you think that on our model, the Earth is rotating at 1,000 miles at once per day, and then the air is not moving at all? Is that what you think is happening on our model?
Hey, what happens? Oh, I'm sorry. To go for Tacori,
actually, if you want to talk about the air,
I'm asking what you think happens on our model.
Oh, my bad.
Because otherwise you're just strawman. Otherwise you're strawmanning, right? On our model, you have the ground, the Earth, the globe, which is spinning once per day. At the equator, that's around 1,000 miles an hour. And the air moves with the ground.
Oh my God.
It's due to something called there's a word for it. It's an interface effect, I think. I think that's what it's called. But essentially, the ground provides friction for the air and drags it along. That's how it works on our model. So if you're going to propose something else, it's a straw man.
May I explain?
Wait
may
a
I
minute.
explain something really quick?
Okay, go ahead.
Listen, the reason we know that the Earth is not moving and airflow proves this is because wind can go in multiple directions, multiple different directions at multiple different speeds, indicating that it is not the Earth spinning.
Relative to the
Because
ground,
if
right?
the Earth was spinning, there would be some type of observation that we could see, like trees would be blowing. For example, people
That's
could jump up
nonsense.
and
That's
end up,
complete
No,
nonsense.
that's
miles
actually
away.
facts.
No, that's
actually facts.
nonsense.
I'm
It
gonna
is,
tell you
because
how it's facts. Because check
Thank you,
this out.
Tacori.
The faster, listen, the faster an object, watch this. The faster an object moves, the more wind it'll be able to produce. The more mass an object have, the more wind it will be able to produce. So let's say, for instance, if you got a fan, you turn that fan on at level 1, that fan ain't gonna hardly blow any air. But if you turn that fan on to level 3, it's gonna blow a heck of a lot of air. So
This
it's
is
due to the fact that that fan is moving faster than it was at level 1, which is producing all of that air.
To be clear,
So
you're currently trying to tell us what we think our model is. But
no, I'm telling you
isn't
what
it-
reality is.
so you think reality is a globe. I'm glad
I'm
you
telling
agree.
you what reality is.
I'm glad you agree reality is a
tells
globe.
you that
About
the Earth,
60
which
seconds.
is, I'm telling you that reality tells us that if an airplane can produce so much wind due to the speed that it's moving that it can yank somebody out of their airplane that's not in a seatbelt and yank them into the sky and kill them, and that's an airplane, then what make you think that that wind force wouldn't tear anything up from an Earth that's spinning at 1,000 miles an hour, and
This
that's
is-
like
All right,
6.
let's give Dr.
that's
Blitz
6.
and Peter a chance to respond.
Okay, I was trying to get to my point.
I mean, look. So you're currently mischaracterizing what the globe model is, which is understandable because some of these things are. Well, I don't want to say anything rude. The point is you're misrepresenting our model, but we can actually just do experiments that test whether things are rotating. There's something called a Sagnac interferometer. This is basically you might think of it as a ring laser gyroscope. That's you probably heard of it as. Essentially, if you put one of these things on a merry-go-round, for example, and you spin the merry-go-round, you will be able to measure via an interference effect with the light traveling in two different directions. You will measure the rate at which the merry-go-round is spinning. And if you take one of these devices and just plop it on the ground, you will measure 15 degrees per hour of rotation. So, I mean, it's right there. It picks up rotation from merry-go-rounds, and when you put it on the ground, it picks up rotation from something. The ground is rotating.
I'm going to give you a chance to respond to Corey, and then Matthew, once you stop laughing while other people are speaking, we'll give you a chance to respond too, but let's go to Corey first.
Okay, here's the thing about that. Listen, we know about aerodynamics. We all know about aerodynamics. We all know that the faster objects move, the more wind speed that it's going to actually produce. This is a fact. So you're talking about an Earth that's like 6 times 10 to the 24 power kilograms, moving at 1,000 miles an hour. Do you know how fast a hurricane rotates?
200 kilometers an hour or so.
200 miles an hour? Okay, so 200 miles an hour. So, what type of destruction do that hurricane cause moving at 200 miles an hour in rotation?
It causes significant destruction on things that are not moving at 200 miles an hour as well.
Significant destruction. So, Earth rotating like that 5 times its speed and has way more mass than it, it's not causing no destruction from that wind?
No, because the wind is moving at the same speed as everything else. So it feels like there's no wind.
The wind on a hurricane is also moving 200 miles an hour on
it's moving. It's moving faster than everything else, right?
It's moving faster than everything. So if the wind is moving with the Earth's speed of rotation, are you telling me that the wind around us right now is moving at 1,000 miles an hour?
Relative to some fixed point in space, sure. Relative to the surface of the Earth.
Atmosphere?
Relative to the surface of the Earth, it's not moving at all, unless it's like windy or whatever. Then it might be moving a few miles an hour.
So it's not moving. So let me get this straight. It's not moving at all relatively to the surface of the Earth. Is it moving
Roughly.
so is it moving at 1,000 miles period around us?
Motion is always relative, so you have to tell me relative to what.
Is it moving? Is the wind around us moving at 1,000 miles per hour
Relative
right
to
now
what?
around us in this
Relative to the ground, relative to you and me, relative to the sun, relative to the moon, relative to, I don't know, like a Formula One car, like relative to what?
Just
May I make an interjection? I have actually a question here. You mentioned the Sagnac effect and the interferometry device utilizing ring laser gyros. The contradiction that you put forth is that a plane, or let's say a helicopter hovering in the air, cannot detect that the ground is moving beneath it because you say it's going with the air. But the contradiction is the ring laser gyroscope being the only thing, this expensive little computer box, that can feel the rotation. And that's what you want people to believe, that a little laser box, little computerized laser box sitting on the ground, right?
You know, it doesn't require a computer,
Earth, right? And then
it doesn't require a computer.
The contradiction you have to understand the contradiction you put forth. The helicopter hovering in place does not have the ground moving beneath it.
Complexity is not contradiction.
Hey, no. That you have to understand the contradiction you put forth.
It's complexity, not contradiction.
Which one are you going to go with?
Complexity is not contradiction, except to a simple mind.
Well, then you will understand my simple question, though. So, is it
your simple question is reductionist?
Is the helicopter and the air connected to the Earth, and that's why it doesn't move? And then the ring laser gyro box, which is connected to the Earth, can feel it, even though nothing else.
Okay, I understand. I understand the confusion.
Nothing else on the Earth demonstrates anything that the Earth is moving.
I understand the confusion. I can clarify.
Right.
So the helicopter,
I hope so.
So the helicopter is in some sense attached to the Earth in that it's sitting in the air and the air is moving with the Earth. So that's certainly true. That's correct characterization. However, the trouble with the ring laser gyro is that the light, this is a fundamental postulate of special relativity, and this was shown to be correct experimentally. I can cite you a 1,000 studies if you'd like. Light doesn't actually care about what setting it's in. It will always move at the same speed. So that's how it can be. So essentially light travels as if it wasn't attached to anything. This is a very, very strange feature of our universe, but it seems to be true. And it seems to be borne out in all modern scientific endeavors. This is why things like, like I mentioned, why things like medical radiation devices work. This is why things like, what else did I mention? I mentioned, why particle accelerators work, why nuclear energy works. It's for the same reason. So this idea that light doesn't actually care about whether it's moving or not, it will just act as if it's starting from something that's stationary. That's what makes it different from the helicopter. It's not attached to the Earth in that sense.
This is an opportunity where if either side would be willing to, there are a couple of people in chat who said we're kind of losing the big picture here. We're so in the thick of the details that maybe it could be explained just how this in particular, from a big picture view, would be evidence for or against the flat Earth.
Oh, I got it. I nailed it with that it's a contradiction. And there's no way
it's not a contradiction. It's just special relativity.
Because if the helicopter is hovering above the Earth, right? Now this is from my previous debate. How high does the helicopter have to be above the Earth before the Earth starts moving beneath it?
It can't go high enough because it won't be able to fly.
I agree with you. It can't go high enough to have
there just won't be enough air.
Yeah.
There just won't be enough air to hover.
I think a lot of people still, though, Matthew, I think that a lot of people still are big picture-wise tying this back to flat versus globe.
So the idea is that if we can show that the Earth is rotating underneath us, which we can, then it can't be flat because you must have some sort of rotation about some axis. And the flat earthers are not prepared to say that the Earth is like on a merry-go-round. So if we can show that it's rotating, which we can, then we can show that the Earth is a globe, or at least
I think
not
you're just suggesting it. It's like a theory. Like
should I give you experimental evidence?
Experimental evidence?
Yeah,
You
like
mean like
scientific
more
experiments.
theories, like you want to give me numbers rather than like a
num-
realistic
Just
example
to be,
utilizing practical effects
I
that
want to give
show the Earth is moving?
I
Because
want to
you
give
cannot.
I want to give Dr. Blitz, I'll give you a chance to respond, but just to be sure that everybody's on the same page. So it sounds like Matthew and Hakeem, or Matthew, Hakeem, and Tacori, you both you'd bite the bullet and you'd say, yes, we're challenged. Our flat Earth view is challenged if the Earth is indeed rotating. You're willing to concede that, and now it's just a matter of like, do we have the evidence of it rotating? We're all on the
Well,
same page there, right?
that's the thing is what I'm familiar with this idea of the Sagnac effect and the interferometry device,
Just before we talk
but
about
it's
that effect, I
facetious.
just want to
That's
see
the thing.
if we can just to clarify for the big picture is just that it sounds like you guys would say yes. Like if there is evidence of rotation, that is a challenge. It's a bigger challenge for our view than the
Oh,
globe
agreed,
view.
agreed.
Okay.
Like if there was like 1,000-mile-an-hour wind, yeah, we would be like, wow, there's some sort
Don't
of
straw man in
reason that.
answering the question. This
No,
isn't
I
that hard.
answered
Okay,
it.
I
I
think you
answered it.
said
I just
yes,
answered it.
despite bringing out the
Yes,
wind. But
if there was some type of rotation that we could observe and really test rather than just a computerized laser box that has to be programmed a certain way and that does not correspond with reality, that indicates a huge contradiction to the idea that the Earth is rotating.
all right,
So
we'll give the globe side a chance then,
yeah,
as I think
just
that they would say there is evidence for it. Go ahead, guys.
just
yeah.
to be clear, it's not a computerized thing, and then Peter, by all means, but it's not a computerized thing. The Sagnac effect is from over 100 years ago. They didn't have computers back then. You can run a ring laser gyroscope. Well, you can't run lasers without electronics, but you can develop a Sagnac interferometer with just like candles and stuff. Like you don't need computerized whatever. This was done before computers existed.
And are these candles moving with the atmosphere or not?
They're moving. They would be on the ground or on your table.
I don't think you're understanding the contradiction you presented here.
I don't think you're understanding anything, Matthew.
Of course, you have to say that. Of course.
It's obvious.
This involves
it's just obvious.
Right? You're being pointed out these crucial errors to your theory.
No, you are just being
It's a
reductionist
crucial
and
error.
showing your ignorance.
No,
This
no.
is complexity, not contradiction. But you can't tell the difference because your mind is too simple.
Or it's reality versus fantasy.
No, it's just complexity.
It's reality versus fantasy because I don't need to
Just to get back down
make
to the
any
actual
claims.
arguments.
Like
So,
I don't need to go
Blitz,
through some
I
long
can
thing.
take the ball for like we
By
see
all
too
means.
far or sunset. If
Why don't we talk about
Whatever you
sunset
want.
because they
Whatever you want.
didn't talk about that.
Whatever you want. What do you want to know about suns on a flat Earth? What would you like to know?
how about you actually address my experiment instead of just trying to nitpick it and failing like a
Okay, what do you want? What do you want to know? I'll be cool about this. I disagree.
Why doesn't the sun follow an arctangent function if it's supposedly moving away according to perspective?
Well, what you got to understand is that perspective it's profoundly essential for our understanding of celestial mechanics. What I said in my intro is about our personal dome of perspective, which is what modulates how we observe these phenomena. Now, what happens with the sun, I would describe it like this. Say you were directly under the path of an airplane that flies. If you were directly underneath the path of an airplane that flies, it would seemingly come from the vanishing point of the horizon, which is at your eye level. But as it approaches you, you would have to raise your eyes up to see it. And then when the point of which the sun, or not the sun, the plane is directly above you, it would be at your zenith point. You would have to look directly above you to see it. And as the plane flies away, you'd have to, of course, turn and lower your vision to see the plane go away. The plane isn't going up and down over you. That's ridiculous, right? That's like how some people would characterize the sun moving underneath the flat Earth. But really, a good example of this is this. Psalm 19, how it talks about how the sun, it's like on a circuit above the earth, right? That's
not what Psalm 19 says.
we
But
can go over that too. But you showed that in your experiment that the sun does in fact have a circular path above the earth, and you agreed to that. You agreed to that. Now watch, just understand the sun is over us, right? So it appears to rise above us. And then the subsolar point is also a crucial factor, which is how we get seasons. The annual cyclical movement of the subsolar point from tropic to tropic. That's how we get seasons. But to put a basic answer for your question about the sun, it has a circular path above us that expands. It has a tight circle of the Tropic of Cancer in the summer solstice, and this path expands to the Tropic of Capricorn in the winter.
I want to give you a
It's
chance to
very
share your
interesting.
screen, Peter. I just took that down just for the moment, just because sometimes some of the members of the audience will get confused and think that it's Matthew that was sharing while he was explaining. But if you want to share that again, you're welcome to, if you would like to use it to make your point, Peter.
yeah. Give me 1 second here. Okay. So Matthew,
Right.
do you see the diagram?
I can kind of see it. It's kind of small because I'm using my phone.
It's a little smaller
Okay.
this time than last time.
Yeah, I can make it
There
larger.
it is. Perfect.
This shows that if something is moving away as you're describing, like with the plane or like with a Robothmist sun, it should
You don't have
follow an
to call it
arctangent
that.
function. There is no way to argue this. This is pure trigonometry, pure math, and it is very simple. It is some of the simplest trigonometry that you can do. There is no way to argue. If something is moving away according to perspective, then its elevation above eye level will follow an arctangent function. That's how perspective works. That's why there's such a thing as a vanishing point. That's how it works.
But you're not taking into account distortions in perspective due to our dome of perspective, how we
Due to
observe
what?
light.
Due
On
to
one of your
what?
diagrams, watch. There is such thing as perspective. You're touching on reality. You have one diagram also that looks like a dome shape that you're not showing right now, but you have to take that into account how
I
perspective
made this
works.
diagram. I don't know what
Yeah.
dome diagram you're talking about.
You have to understand like how we perceive light, how any lens or eye will receive light, how it comes
Matthew,
straight to us.
I have a question.
Yes.
So this
Yes,
is
yes.
so
it's-
right. Sorry, Tacori.
Go ahead.
Okay. So perspective has been well known since I guess the mid 1600s or so with the Renaissance when they kind of figured out how to draw in perspective, right? It's like pretty well understood, right? Like I'm sure that we agree on like that the mathematics of perspective is pretty well understood.
We might disagree on specifics, but more or less perspective exists.
Yeah. And we understand how to like draw accurately using perspective. We understand how to figure out how far something away is based off of how big it is, things like this, right?
Well,
I
we may or
don't
may
think
not
that
agree on the
these guys
specifics.
do know that.
Okay, so all
may
I
disagree.
wanted to convey, all I wanted to ask really is perspective is so down to earth, so well studied that I should be able to find anything I want to learn about perspective in a textbook, right? So can I find this dome of vision in a textbook?
Well, it's actually incorrect. It's kind of hard to find, like because I'm compiling images for a book. I'm compiling images for a book specifically on celestial mechanics, and it's hard to find it. They exist.
Why might it be hard to find?
Google algorithms.
No, I'm talking about textbooks. I'm talking about textbooks. Not
you mean
like
you mean like
pre-internet.
how am I gonna find a textbook from 300 years ago?
No, just from like the 1930s or whatever.
Hold on,
Like,
let
A
me
lot
get
of books.
something
That's a ridiculous question,
You
but
wanna-
or the 1980s.
Yeah,
or
that's a
just
ridiculous
text,
question.
like paper.
Like you want me to find a dude? I think that
let me
might
get
be a
something
ridiculous
straight.
question. That's
I'm just asking. It should be in a physics
Like, how-
textbook where they
how
talk
hard
about
is it?
optics, right?
well, what you have to do is you have to research other phenomena, such as anti-crepuscular rays, as well as the analemma.
Yeah, those things are talked about in standard university level physics textbooks when they
Let's
talk
talk
about
about
Let's talk
optics.
about it. Let's talk about how we disagree.
Well, no,
Let's talk
I'm just
about
wondering
how-
if this dome of vision thing is real, why can't I
It
find
is.
it in any textbooks?
Hold on, wait
Well,
a
it's
minute,
not-
wait a minute.
All right,
Maybe let me make it real clear on this azimuthal dome. Azimuthal dome perspective that we're talking about. It's very simple. Look at one part of the sky. Look up. Look at the other part of the sky. It'll give you like a dome. That's what the perspective will give you, like a dome. That's all around, 360 degrees. So
Okay.
yes, that azimuthal dome perspective is real.
Yes.
If you want to look at something going over the sky from one angle to the next angle, and you follow that, like if you see a plane, your head is going to move like a rainbow above
I absolutely
one
agree
area
that
to
we,
the other. That's what we're
I,
talking about, an azimuthal dome perspective.
Yeah,
but not
that's
quite.
fine.
That's not quite what you're talking about. So I agree that you can measure things in the sky with angles. Like you can say, oh, it's 30 degrees up, and then it's 80 degrees north or something, or 80 degrees from north. That's fine. I agree. But Matthew is making a separate claim, namely that this mystical dome of vision is influencing how perspective works. And that's the claim that I would like to see substantiated in, say, an optics textbook.
It is substantiated.
Where?
Like I said, I gave you 2 examples.
No, I want to see this. I want to see this in like an optics textbook. Does that exist?
Well, if you're smart enough, you can find it.
That you can. Hold
I mean,
on.
I've taught out of
Can I just
textbooks
let
like
me,
this.
let me say it really quick. Okay, listen. Look up how anti-crepuscular rays are formed. Okay, look at how it would be on a flat plane. How our dome of perspective will warp the paths of the lights above us.
No, it
Now,
actually proves that it's not
anti-crepuscular, but also the
sun.
analemma. The analemma is also evidence
you don't want to
of
bring
this
up the
perspective
analemma.
distortion. Listen, about the analemma, Globers say that it is a result of axial tilt, which causes the analemma. However, the stationary position of Polaris and the fixed rotation of stars around it disprove the notion of axial tilt.
False.
The implication of that is that the analemma is a more accurate reasoning for how we get the analemma because of these perspective distortions as a result
So
of how
you're naming
our dome
all
of
of these other
observation-
phenomena
how
that
our dome of
destroy a flat
observation-
Earth that
No,
you
it
think
doesn't.
this magical rescuing device explains, and you're using that as a way to argue that this magical rescuing device can also explain other evidence that destroys a flat Earth.
Well, what it is, it's
That's not
demonstrated with
evidence for your magical
listen,
rescuing device.
It's demonstrated with practical effects, not computer models.
Matthew,
So demonstrate it.
I just hold on one sec.
So-
Just
I did on my YouTube
think
page. Check out my YouTube.
Demonstrate
Tacori-
it here. You're in a debate here, not on your YouTube
I don't
page.
have all my
I can give you a
materials. I mean,
chance.
I'm doing a debate.
You have your mouth and your
Tacori,
brain.
I want to give you a
Yeah.
chance to share your. Or it looks like you've already
Yeah,
shared
I
your
want
screen.
to
If you had a point you want to
video
make, I do want to encourage. If you
because I
guys could do me,
promised that I
if
was
you
gonna
guys could
show
do
it.
me a hold on
there
one
it
second.
is.
Hold on. If you could do me a favor and just not share your screen while someone. Otherwise, if you share your screen while someone's talking, oftentimes the audience thinks that the person who's speaking is the one who shared it, and they start trying to make sense of it in light of what the person is
Okay,
saying when it's
I
not
wanted to share my
matched.
screen
You
and
can
show his
definitely
video.
go for it right
of
now. I wasn't
California.
trying to reprimand you or anything. Just
And I'll
So-
narrate a little bit. Can I narrate?
Yeah, he can narrate. It's his video, so of course he's gonna. Yeah, it's his video, so he's gonna narrate.
Yeah, I just wanted to say a little bit as it's playing that it shows that Southern California is flat. It's not playing.
Yeah, I'm gonna share it on YouTube.
you got it. We're ready for that share. Go ahead, Tacori. Folks, thanks for your patience. I keep forgetting I
Yeah,
had my
I was
myself
gonna say
muted.
that I was gonna share it on YouTube
On YouTube,
because
as
I'm not.
Are you going to be playing a video of a guy jumping with a flag?
No.
Okay, just checking.
No, why would you say that?
if you're
No
sharing
reason.
it, if you have a video you want to share, I think you're
Yeah,
saying you want to share a YouTube video. The
I
audience
have
can't
one.
see it, but if you want the audience to see it, you have to share it through the Zoom call.
Yeah, y'all can keep talking to I pull it up.
Okay, you got it.
Y'all can keep talking till I pull it up.
You got it. Go ahead, Matthew. I think you were saying something.
Okay, well, yeah, just that's the video I wanted to show in my introduction of how there is no curvature. The amount that is supposed to be there is not there.
Wait, so you're changing the subject now?
No, that's I'm addressing the video that should be playing. Unless you want to continue
can't
on.
see a
I
video,
thought we
by
were
the way.
talking about sunset and perspective. I thought that's what we were
Okay.
what we were talking
We
about.
can continue talking about that if you'd like. What would you like to know?
Oh my gosh, we just completely reset
So-
now. We
I
were in
asked
the
you a
middle.
question. What you brought up that we're
Look,
talking about
so-
something. I asked you what you want to know.
So the whole endeavor of modern science, and I hope you agree, is that we try to quantify things. We try to describe things numerically so that we can make predictions. And by the way, I'm still talking about perspective and all this stuff. So if we were really interested in trying to understand how things look and why they look a certain way when they're a certain distance away, there should be some formulas I could use that invoke this azimuthal grid of vision. I should be able to find that in a textbook somewhere, right? Otherwise, we wouldn't know how to figure out, how big we should draw a house if it's behind a building in a painting. Like, there should be some formulas. Can you show me?
I disagree with you because it's funny that even like the maps, people are starting to realize that all the maps are wrong in regards to like the size of, say, Greenland versus Africa.
That's not a new realization. That has been known since the maps were drawn.
So you know that there's distortion on maps.
Yes, it's physically impossible to
draw.
draw a flat paper map of a spherical surface. That's why every map has distortion. This is known. This has been documented ever since the maps were drawn.
And even globes too, like a physical globe.
No, the physical globes are accurate. The physical globe is the only thing that's accurate.
Are physical globes in the shape of an oblate spheroid?
They can be if they're accurate enough.
So they're not accurate.
They're accurate to within a very high degree of precision.
Gotcha.
Hey, bro, I got your video up.
Oh, nice. Yeah, just play it whenever you can. I'm up in the hills. It's beautiful. This is the city of Fullerton, California.
This is the experiment that you did, right?
This is
the experiment you did on the hill.
Well, partly, yeah. I could put this against the idea that there is any curvature on the Earth. Now, the issue here is I'm not just looking at one point, say 10 miles away. I'm looking at multiple points in excess of 30 plus miles away. You can't see it clearly, but I just showed downtown Los Angeles. This is like west of here. There, and then the edge is the ocean because that's just how the water is. I'm in Southern California. Fullerton, it's considered like kind of coastal, but we're not near. We're miles from the beach. But as you see, gentlemen, there is no curvature up here. And this is not any digital effects. This is just straight up me in the hills.
Exactly what would you expect to see if you were on a globe doing this?
Matthew,
if I was on a globe, I would expect to see some sort of curvature. If not,
okay, that's just your ignorance.
No. If
just
not
a straw
8
man.
inches per mile square, you asked me a question. If not 8 inches per mile square, I would expect to see something.
Well, then you're just wrong.
To see I'm wrong thinking, wait a minute.
Yes.
You're right.
You are wrong.
If I'm thinking there should be curvature, I would be wrong. So I agree
using
with you
this
again.
methodology,
I agree with you
you're
again.
wrong.
Like, look at
Matthew,
there is no curvature.
Using this methodology to find curvature is wrong.
You have
Matthew,
to
you said that this was an experiment, yeah?
Yes, you have to identify multiple.
What is the
locations.
independent variable of this experiment?
You lost me with your confusing word salad talk. You have to look at what I'm showing.
Presumably, you and I agree that science is good, right? Like we like the scientific method.
Okay, this video is not taking place in a theory. This video is not. I was
just asking for you to describe an experiment. A scientific experiment has independent variables. It has dependent variables. It has statistical analysis. It has a null hypothesis. Lots of pieces to an experiment. Do you have any of those?
So what you're saying is my science, I need to get more people involved. I need to get more scientists. I need to get a whole team of people. And I agree with you.
You're very bad at listening, Matthew.
I would love to have more people working on my science, help me understand what I don't know, and to help me articulate my ideas better. So any limitations you're experiencing from me, I apologize. Nobody's perfect. But I do think that my science could go to the next level. My science could definitely go to the next level.
Failure to make an argument at all from evidence is not a simple imperfection. We're not talking about.
I said the Earth is flat.
Yeah, you failed to show how that would be evidence for anything.
Hey,
By the way,
can I say something real quick?
Can I bring something up about that video? 1 sec, Tacori. This will be quite quick.
Yeah, I didn't speak in a minute, so
I will be 15 seconds, I promise. So the last thing I said in my opener was, do you throw all of the scientific evidence away from the last 300 years in favor of it looks flat to me? And Matthew, I think you just
that's appealing to authority, appealing to credentials.
I don't trust the government. I think there's some very corrupt stuff that happened in the government. I do not trust them. I think a lot of what we're seeing is like illegal that the government is doing. And I don't think we're ape men. I don't think we're on a ball.
I'm sorry, did I say government?
Science too.
Yeah, well, that is actually sanctioned by the
government. Government controls science and money.
Oh, which one?
Science.
Which government controls science? Which one?
Our government funds specifically
the American government?
biolabs across the face of the earth, such as let's not talk about that. But
wait, which government? The United States government? I don't live in the United States.
Every government.
Hey, check this out.
That's cool, I guess. I don't know.
This is sheer pigeon chess.
When they said this, when they said that wind can blow planes to their direct location at that direct time, that's when I was like, I'm not about to go back and forth with these folks. I was like, you can go and have it. Because if you tell somebody that and they believe that in their heart, man, I don't know what to tell them.
What are you talking about, Tacori?
Yeah, once y'all said that a darn wind can blow the planes to their direct location. Yeah, like when we first opened.
Oh, okay. So you're trying to take something we said out of context and misconstrue it and claim victory.
Asked you, how would y'all listen? When I asked you, how would y'all get to y'all location if the Earth is spinning at 1,000 miles an hour and it's spinning to the east, and it already spent 5,700 and something miles to the east? You said the wind.
So let me be clear here. We were talking about sunset and perspective. You guys changed subjects not once, but twice now, back to this thing where you were just demonstrating abject ignorance of rest frames. No. Now you're claiming victory over this.
First started doing the Q&A. This is when we first started doing the Q&A. And once you said what you said, I was like, nah. I'm not about
so
wasting
you've
my
changed
breath.
subjects twice now away from sunset and perspective.
No. I'm not changing the subject. I was
yes,
just
you
saying
are. You're changing the subject.
No, listen. I'm saying the reason why I didn't go back and forth with y'all like that, and I let Matthew do it, was because of y'all first answer when we was talking about
when you were showing abject ignorance of rest frames. That's right. I remembered it. I remember.
We showing abstract ignorance, but you the one talking about wind can blow planes to their
we
location.
didn't say that. You're just showing abject ignorance of rest frames. We were talking about rest frames. A plane moving through the atmosphere is in a certain rest frame. The atmosphere is also in a certain rest frame. The motion of those things must be described according to a rest frame, like Blitz said. But you guys don't understand that. You don't seem to understand rest frames.
Listen. We trying to see how did it get to, because you got to get to that airport at a specific time. That's what you got to get. You got.
I need both y'all in my class.
Hold on, wait a minute.
Like, I just gotta nail you with Newtonian physics.
Oh my goodness! Can I speak?
I don't want to downgrade. I don't want to downgrade my intelligence. Sorry.
Let's give Tacori a chance to finish that thought. Go ahead, Tacori.
Yeah, because this the last thing I'm gonna say, and I'm gonna let Matthew just get at y'all, because this is crazy.
Because he's got a worse attitude.
Yeah, this is crazy because I literally asked y'all, how would it get that specific time? How would it travel from from Europe all the way to I think it's called Buku, Africa, and I think in Ghana, because that's where the flight pattern was at. How did it travel and get there 5 hours and 59 minutes when by the time they traveled there, it spent to the east at 5,700 and something miles? which means it left y'all 5,700 some miles behind. How could y'all get there at that specific time using that specific path if your landmass is spin or your location is spinning away from you 1,000 miles an hour for 5 hours straight?
Yeah, Tacori, before you bow out, can I ask you one question about
Well,
that?
I'm not buying that. I'm just.
Can I ask you a question about what you just said?
I need you to answer that question.
I didn't hear a question.
Oh
Maybe I
my
missed it.
goodness.
I heard a monologue. I'm sorry. Maybe I missed a question if there was one.
I'm gonna say it again. I'm gonna say it real slow. I'm gonna say
make sure it
I don't
ends in
know
a
how to
question
make
mark.
this as slow as possible, but I'm gonna try my best to hope y'all can understand this.
Slower isn't needed.
Listen. How do the plane one location get to another in 5 hours?
Oh yeah, okay. I was getting to answering that.
5 hours, it moved east 5,000 miles away from it. How do it get there at its precise time? If it
Yeah,
moved,
in order for you to understand my
spend
answer,
5,000.
I have to ask you a question. Okay, so I'm getting toward answering that. Can I ask you a question?
No, you can answer the question. You don't need to answer the question with a question. I just need you to answer
I'm
with an
getting
answer.
toward that, but I have very low confidence right now that any answer I give will be understood. Okay, so I need to
No,
I need
it's
to know
just
that
not
you'll
gonna make no
understand.
sense because it's impossible. You can't get there at that
It's
certain
rest
time
frames.
if your
Rest
landmass
frames
keeps
is the
spinning
answer,
away
but you
from
don't know, you don't
faster than a
understand that.
plane.
Oh my
3
gosh.
times faster than a plane at that, to be exact.
It's according
So
to a
can you
rest
answer
frame.
that question?
Okay, I'll just ask my question instead of asking permission, because clearly you're just trying to bulldoze this. If let's say you're riding in the back of a pickup truck, okay, you're just moving along, let's say at 30 miles per hour, and you're holding a ping pong ball in your hand, and you throw that ping pong ball straight upward into the air. Now, let's say we measure the speed of the ping pong ball relative to the asphalt beneath the pickup truck, right? Right before you throw it. It's also going to be 30 miles per hour, right? But a moment after you throw it, a millisecond after you throw it, when there's 1 millimeter between your hand and the ping pong ball, what the heck are you just shaking your head for? I haven't even gotten to the point.
You cannot compare the speed of a pickup truck to an airplane.
You're trying to preempt my point. I haven't even made my point yet. Listen, try listening.
Walk into the trap. It's okay.
Just try listening. Use your ears that God gave you. Okay, so
2 ears, 1 mouth, right?
millisecond after the ping pong ball leaves your hand, it's a millimeter above your hand. How fast do you think the ping pong ball is moving relative to the asphalt under the pickup truck?
You say if you throw the ping pong up?
Yes, when it's a millimeter off your hand, a millisecond after you throw it.
Sir, you can't compare a millimeter off of a ball out of your hand to a plane that's hundreds and thousands of feet.
Okay, so you don't know the answer then?
You got crazy comparisons, bro. Oh my
I haven't made
God,
the point yet.
Crazy comparisons.
I haven't made the point yet. I asked a simple question. I asked a simple question.
Like
I asked a simple question that you can't answer. I haven't made the point yet.
Hey, Matthew, you can go and get him. I'm done.
Apparently, you don't know the answer.
Just tell us what happens. You don't have to.
The ping pong ball will still be moving roughly 30 miles per hour relative to the asphalt. It won't have had time to change its velocity.
And so what you're saying is even a ping pong ball moving at 30 miles an hour, the Earth still does not move beneath it. At no point.
That wasn't the point of what he was saying. No.
At no point did you indicate that the Earth was moving at any time. You indicated that only
the truck is moving.
And in your example, you only indicated that the truck and the ping pong ball were moving.
The analogy here is the truck is the Earth and the ping pong ball is the airplane.
Yes.
The truck is moving. And the ping pong ball moves with the truck.
He said your examples were highly inaccurate. To put in my words, highly inaccurate.
Obviously, it shares certain traits with the with the real scenario we're talking about, and it also does not share certain traits with the scenario we're talking about. I'm not saying it shares every trait, that it's an identical scenario. That's not what I'm saying.
If the truck is the Earth, then you think the ground is like the solar system.
Yes,
Sure,
roughly.
So
in this
you think the
analogy,
solar
roughly.
system isn't moving?
I said roughly. It's
Well,
an
but the
approximate.
ground is moving because the Earth is rotating, so the solar system,
According to a false theory.
so the solar system would be like the center of the galaxy, then I guess.
Hey,
The-
And then, like, we could wind the
exactly
analogy all the way back if you want.
I'm gonna tell you
it's a bad
exactly why that's a
analogy.
crazy analogy. Because, like I was saying at first, that's why I knew y'all was going. Because I know these talking points. If you like a pickup truck,
It's
at
not
30
a
miles an
talking
hour-
point. It's a concept, and you don't know the
listen,
concept.
okay, it's a concept. Okay,
I
let
teach
me
this to
finish.
18-year-olds.
Let me finish.
By the way.
I know. I hope y'all ain't knocked y'all out already. Where y'all kind of keep talking over me because y'all too scared to let me speak. So here's the thing.
That's not what's going
I
on.
compare a 30-mile-an-hour moving truck to a plane that's moving at I don't know, like 757 miles an hour, because the wind strength is completely different on a pickup truck and the plane. If I'm in a darn pickup truck, I don't need moving at 30 miles an hour. I don't need to strap down in something to keep from falling. Or getting yanked off the pickup truck. But I need a seatbelt, and I need that door closed and everything on that airplane closed if I need to stay within that airplane.
Pilots fly in airplanes that have open
air.
cockpits.
So that's a
thing.
messed up analogy, bro. You got to use
Also,
another one.
hold on. What happens if you stick your hand outside of a moving vehicle that's going 90 miles an hour?
You say what?
You stick your hand outside of a window in like a car that's driving 90 miles an hour. What do you feel on your hand?
You feel wind.
Yeah, so if you just like chucked I don't know, some feathers out a window in a car that's going 90 miles an hour, they'll go back, right? Because of air resistance, right?
Oh, now you get it now.
Right,
Now
but
you get it
inside
now.
the car, if you throw the feathers, do they go back to do they go to the back of the car?
They just go back. I don't know where
they just go down. They just go up and down.
The air is blocked by the windshield.
Probably
that's why they call it that. That's probably why they call it that.
Great.
A windshield.
Great, you're getting it. So no, this is great. This is awesome. Because in a car, there is something keeping the air moving with the car. It's the glass around the car, right? And the body of the car. On the Earth, there is something keeping the atmosphere moving with the Earth. I think it's called gravity and friction. It's the same situation.
It's a false theory. It's a debunked theory.
You have to prove gravity.
Oh, do you want to talk about gravity?
Right, so we just answered Tacori's question.
I do want to
we
give
just
I
answered
give a chance
Tacori's
to respond.
question.
Gravity's
So
dead. So
I
you're
do want to give
really quick.
gentlemen.
Oh, sorry.
I need you. Hold on. Bear with me here. I want to give one chance. So Matthew, we'll kick it over to you, and then it sounds like Peter, you want to say something, and then we'll go to Tacori and then Dr. Blitz, since Dr. Blitz made the last point.
Okay, so for your theory to be, it's like what you're saying to be true is you're necessitating a theory for what you're saying to be true. There needs to be this thing for what you're saying to be true, and that thing is gravity, right? Your theory depends on a theory.
That's not correct.
That's literally what he said.
No, Tacori.
Gravity is his answer.
You and Tacori presented
like
an example for something that was supposed to completely debunk the globe.
Incorrect. We're talking about a truck and a ping pong ball.
No, going back to the airplane flight from Russia to Africa. Tacori asked the question, how could this be? We answered his question. We explained how it could be on a globe.
It was an insufficient answer, though. It did not answer his question.
Just because you reject the answer doesn't mean it's an insufficient answer.
One sec.
Listen,
yeah,
Peter,
your answer was a theory. Your answer was
a messed up analogy, bro.
Hold on one second. Okay. Well, all right. It sounds like Peter, you got your point, and then we'll give a chance to Tacori, and then we'll go back to Dr. Blitz.
Yeah, because I'm not asking them that question again, because they pretty much don't understand how to actually do comparisons and actually duplicate things. Duplicate, meaning the same. That analogy that you use is not even the same. So here's the thing: you say gravity exists, right? That's what you say. And yes, I am changing the topic because you fell horribly on this specific topic of the motion of the earth. So
you ran away from sunsets and
so you
perspective.
saying gravity exists, right? Yeah, you saying gravity exists, right? Okay, so if gravity exists, y'all say gravity needs more mass, right? Needs more mass to act on
It
objects.
doesn't. I don't know what you mean by needs more mass. Gravity acts on things with
on
mass.
greater
Yes.
masses. It acts
Yes.
strong on greater. Okay, all right. Okay, so it acts strong on greater masses. So, I did my research and I found out that according to NASA, the reason that y'all Earth is a sphere is because gravity is pulling equal on all sides, right? It's pulling equal on
Yeah.
all sides. But hold on, wait a
Roughly,
minute. But y'all
nearly
said
equal.
it's an oblate spheroid which has unequal amount of curvature.
Yeah. So the gravity.
Very
So
marginally.
how's it pulling on all sides equal?
I can explain if you want.
Go
Roughly,
ahead.
gravity. So gravity is a central force, what you might call a centripetal force. So it pulls two things towards each other. And so if the Earth was perfectly stationary, which it's not, there would be no other effects to take into account besides gravitational effects. And you'd end up with something that's very nearly perfectly spherical. You know, you might have like volcanoes and stuff that mess around, but setting that aside, it would be perfectly spherical. However, the Earth is spinning. And so there's more than one effect at play here. There's also centripetal acceleration, which, you know, in fact, actually was first described by Newton in 1676.
Do you mean centrifugal?
No, I meant centripetal.
Oh,
different.
Sorry.
Different things. Common. So there's centrifugal force, but that's not what I'm referring to here. Essentially, the motion of the Earth, the pieces on the surface of the Earth near the equator, those are in some sense moving fastest, and so they want to keep moving in the same direction that they're moving in, and so this causes a bulging effect, which in some sense in the Earth's rest frame would manifest as a centrifugal force. And so you'd have an outward pushing force and an inward pulling gravity. The outward pushing force is strongest at the equator, and so you end up with a slight bulge at the equator.
And you see why we say gravity doesn't exist due to the fact that it violates the laws of logic. Because you just
wait a minute. Are you doing this again?
You just gave gravity another identity, which is centrifugal force.
No, it's not. It's not. I didn't say it's centrifugal.
No, listen. Centrifugal
I didn't say it's centrifugal
force that keep objects moving in a circular path. Gravity don't keep objects moving in a circular path.
Force.
It's supposed to. Yeah, that you said. Yeah, centripetal force. You said
centripetal forces is a centripetal force is any force that keeps something moving in a circular path. Yes.
Yes, and which you said that was pretty much what gravity was.
Gravity is a type of centripetal force. Yes.
And that's what we're talking about. One of the laws of logic is that it has to have an identity.
It does. Gravity has its own identity. It is a type of centripetal force.
Doesn't have an identity.
So is the electrostatic force.
Centripetal force, which is the
centripetal force.
A force that keeps it moving in a circular path or keep it orbiting.
It's a type of centripetal force. Yes.
It's supposed to be. It's supposed to attract masses to other masses.
You understand that we can classify forces in different ways, right?
People can't hear if you guys are speaking at the exact same time.
I'm sorry. That's my bad.
Corey,
yeah, he's talking over me.
I'll give you 30 seconds to Corey to finish your thought, and then we'll go over to Dr. Blitz.
Okay, so he said that it's centrifugal force. That's what he said. Centrifugal force is not gravity, but yet you gave gravity some other identity of a phenomenon. That's number one. And even if you want to talk about centrifugal force is not gravity neither. Why you keep like giving these different identities to gravity? If gravity was supposed to be a real force, it's supposed to have its own identity, supposed to have its own function. Every force has its own function. Electromagnetism has its own function. The strong and the weak forces, they have their own forces. But gravity is the only force that can manipulate and assume the identity of other forces and phenomena. Gravity is centrifugal force. Gravity is magnetism. Gravity is it causes things to orbit. Gravity do all of these things and stuff like that. Like, bro, come on now. It violates and it's a contradicting law. Because y'all say that gravity it works more on objects with greater mass. Well, here's the thing. Gravity is supposed to be the reason why all the surface of the water is curved into a ball on y'all model. So if gravity can curve all that ball, I'm almost finished. It could curve all of that water into a ball, that much mass. then it should be, and it can curve a drop of water into a ball. Why can't it curve my cup of water into a ball? Because my cup of water has more mass than a drop of water.
Okay, let's
If
let him
gravity
answer
needs
that
more
question
mass to
about why
act on
can't it
oxygen.
curve your cup of water into a ball.
Blitz, I got something that might help if I can interject.
Sure.
So
I have a
Tacori,
lot to address though. After
Oh,
I
so
have
get-
my I as a person have my own identity, right? So are you going to call it a violation of the laws of logic if someone calls me an uncle and a brother and a son
Bro,
and a
what's up with
husband?
what's up with your comparison of things, bro? That's a force.
All right,
Not
Blitz, it's all
you,
yours.
you made an
can't
attempt.
compare-
You made an
You
attempt.
can't compare
I
you
was
being called
gonna
the
say
uncle
something
to a
similar.
force.
So to be clear, Tacori, you were repeatedly, and I understand that these words sound similar, but you were repeatedly confusing centrifugal forces and centripetal forces. These are different things. Gravity is a type of centripetal force. By the way, so is electrostatics, and so is the strong nuclear force. These are all centripetal forces. It's just a type of force. So you can have centripetal forces, which are center-seeking forces. You have magnetism, which is not centripetal. It is, you might call it toroidal or solenoidal.
No,
or
we
something
talking
like that.
about
But
about that.
the
It don't
point
have
is
its own unique function.
It absolutely does. And the way that
What
the way that we
unique
can tell
function
that
do
is
it
we can
have?
isolate. It results in mass attracting mass at the lowest level. That's the
That's
simplest explanation.
magnetism. That's the attraction part of magnetism.
I mean, that's not true because
That
you can take
is.
non-magnetic
That's
things and they.
magnetism.
Why is it that non-magnetic things?
Mass
Please,
attracting
please.
mass is magnetism,
Sec.
bro.
Let's get
Oh,
all right.
yeah.
Let's give
So,
Dr.
I
Blitz
mean-
30
May I
seconds.
add something? Oh, sorry.
So there's two ways to distinguish magnetism from gravity. Actually, there's several ways. So first, for a magnet, like a bar magnet, the strength of the force falls off as the cube of the distance, whereas the strength of the force for just like a large lead ball that you can test in a laboratory falls off as the square of the distance. That's one way that we know that magnetism and gravity are different things. Another way that we know that magnetism and gravity are different things is that we can find objects that are magnetic and we can find objects that are not magnetic. And the objects that are not magnetic will still experience this gravitational attraction, whereas the magnetic objects will experience, roughly the same gravitational attraction if they have the same mass. So we can control for the magnetic properties of a system, we can control for the mass of the system. And it seems that it is the mass of the system that plays a role for this inverse square law that we observe in a laboratory.
No, listen, maybe you didn't understand what I'm saying. I'm saying gravity. I'm not saying that like gravity is like completely taking a whole concept of all these phenomena. I'm saying that it takes like certain concepts from different phenomena to make its own force. It's like it takes certain
Gravity was
concepts.
before magnetism, right?
Hold on, wait a minute. I don't believe that. That's mainstream science. I don't believe that. Because I don't believe that gravity exists.
I know.
So you can't use that on
Entire
me.
debate summed up just now.
Exists. But here's the thing. Using y'all concepts and stuff, I'm saying that gravity, like it takes certain things from magnetism, it takes certain things from centrifugal force, it takes certain things from surface tension, certain concepts from surface tension. Y'all took those ideas and tried to make it into one force to try to make this force realistic, but it's not realistic. It's just a mixture of different phenomena that exist in its reality. It's not it's not its own unique thing.
The problem is that gravity was first described in like a rigorous way in, I believe it was 1676 by Isaac Newton. And this was about 100 years before magnetism was described in a similar way. It was much before surface tension was described. And in fact, Isaac Newton invented the word centripetal force. So he didn't pull any of this from other things. In fact, the way that we described electrostatics, the way that we described other forces, was using the language that Isaac Newton invented to describe gravity. So if anything, gravity was...
May I make an interjection here? May I make an interjection here?
Right?
May I make an interjection? Okay, so first you said they discovered the idea of gravity, but it was probably just a bad idea because you said later they discovered electromagnetism, which was much more stronger. And even these devices, these devices, I think they're facetious, but the device called a gravimeter, its description is it's meant to nullify any effects of electromagnetics or electrostatics, leaving the final result they attribute to gravity. You have to understand gravity. It was a bad theory when it came out, and it was later debunked, and people came up with better descriptions for reality, better
who
theories
debunked it?
that match reality.
Can you point me to any scientific experiments debunking it?
I've debunked it. I debunk it like this. The main principles of gravity are two things: mass attracting mass, and greater the mass, the greater the force of attraction. But we see that both of these are wrong, because a 100-pound stone will fall at the same rate as a 1-pound stone. That destroys the concept of greater the mass, the greater the force.
Okay, that's basic Newtonian mechanics. You have to convert force and acceleration.
Please let me continue now. Mass attracting mass, we don't see. I've seen they show an experiment with metal balls, but metal balls will have an electromagnetic effect if they have any sort of electricity with them. So you cannot point to that as proof, because also there is an electromagnetic field allegedly throughout the Earth. So it would have an effect
if they're neutral
on those
and in a Faraday cage.
Two things close to each other. So now another reason. Now let's, instead of just looking at the ground, let's look at the sky and disprove gravity.
Oh, I thought that we weren't allowed to look at the sky to prove the shape of the Earth.
No, well, I'm just giving an example. I'm giving an example.
Okay.
The moon is not attracted to the Earth. The moon does not smash into the Earth. The Earth does not attract to the sun. So that's
how do you know? How do you know?
I just proved, because the Earth is not crashing into a sun.
What happens if two things are attracted towards each other?
The moon is not crashing into the Earth, because the moon is not attracted to the Earth.
One moment.
I'm destroying your theory, bro.
There's a YouTube video I might want to show.
Bad taste in your mouth, huh?
No.
Feeling.
You gotta stop blowing your own trumpet, Matthew. It makes you look really bad.
No, it's true. A 100-pound stone will fall at the same rate.
Let me see if this is the right video.
You're conflating acceleration and force.
No, what I'm doing is explaining how the theory is wrong, and you don't like it.
You're explaining wrongly how the theory is wrong.
Get to the rescuing device. Get to the rescuing device.
Oh, now you're trying to borrow my term.
No, I used it before. I've used it before in debates.
Okay.
Then you should recognize it in yourself.
I like that term.
Can I share my screen?
Yeah. I'm still trying to find out how gravity can curve a drop of water into a ball and not my cup of water, since it has more mass than a drop of water.
Can everybody see this?
I can.
Now it's crystal clear, yes.
Okay, so we're about to see circular motion. It's called an orbit, if you will, of a water droplet around a knitting needle. See that? Pretty cool, right? So that's an example of an orbit, but it's not gravitational. It's electrostatic. And we can see that anytime you have a central attracting force, which electrostatics is it's a centripetal force, you can have orbits. So long as something is moving while it's being attracted to the source of the force, it will move, at least approximately, in a circle. So that's all that's happening with the sun with the Earth around the sun, with the moon around the Earth, etc.
You just say it was electromagnetics that makes orbits, not gravity?
That particular one in the video. You just said it,
electrostatics.
That particular one in the video.
That's a very fascinating idea.
Matthew, please don't cut me off.
Very fascinating idea.
The video I just showed you is an example of an orbit being produced by an electrostatic force.
Okay, can you please show me an example of what we're talking about then? Because you cannot show me a video and then I respond to it and say, oh, that's the wrong thing. Can you please show
I was giving you, I'm sorry, maybe you didn't understand why I showed that. I showed that video to illustrate how even under your worldview, where electrostatics is the only thing, orbits can happen.
No, don't say that. Don't say that. No one speaks for me. I don't have a leader. I'm sorry. Do you think that electrostatics is real? Do you think that electrostatics is real? I've seen it.
Okay, so do you agree, Matthew? Do you agree that orbits can happen for electrostatic forces?
It depends on what you regard an orbit.
An orbit is just circular motion around the thing attracting it.
Can electricity make something go in
Not electricity, electrostatics.
I mean, I would say it might be possible, but we would have to look at specific
We just
examples.
saw it, by the way. I just gave you an example.
In that one, I mean, all I saw was one image. I did not see
it was a video.
Anything. I didn't see anything really happening.
Did you see the video?
I thought it was a pen. I thought you were showing me.
It's a knitting needle.
There was a water
droplet of water
that moved
orbiting
around
it.
it. I saw
And
it.
what you didn't show the orientation of it. You didn't.
It was
I mean, it
horizontal.
could have been better. Let's just say it could have been better. I'll
Anyway,
say that. Your
this is
video,
all to
your
say-
example could have been better.
This is all to say.
that.
I mean,
I'll say
you
that.
can pull it up on YouTube if you want, but this is all to say that
I won't do that.
anytime you have a central pointing force, a force that's pulling something towards it, if that thing is moving in a perpendicular direction, that force will draw it into a circle. And that's all that's happening with the Earth around the sun, with the moon around the Earth. There is an attractive force, but the moon is already moving, so it falls in a circle. The sun is attracting the Earth, but the Earth is already moving, so the sun moves in approximately a circle. That's all that's happening. It's the same thing that happens with electrostatics. It's the same thing that happens with gravity.
You did not describe objects being attracted to one another.
I literally just did.
You
That's how
described
orbits
things
happen.
moving around each other. You did not.
That's how orbits
you did not
happen.
describe anything being attracted to anything.
Did you
that's how
take
orbits
physics in
happen.
high school, Matthew?
No.
It's irrelevant. I'm not talking about my high
This
school.
is high
experience.
school level physics that you're failing.
No, what we're talking about
A
is
circular movement
paradigmatic
requires
shift.
acceleration
No.
inward toward the circle.
No, what we're talking about is a paradigmatic shift in a strong astronomical analysis.
So here's the thing about paradigms. As I mentioned actually in my opener, if there was really a paradigm shift happening in this conversation, it wouldn't be on YouTube. It would be at a conference
Don't
or in a
insult
university.
YouTube. Hey, listen, do not insult YouTube and do not insult modern day debates.
I'm not insulting modern day debates. We're just not having a physics conversation.
No.
I think James
You
would
did in your
acknowledge
open-
this is mainly entertainment here, not like academics.
Not paradigm
This might be a good
shifting
opportunity.
physics.
For me to jump in and say, folks, we'll jump into the Q&A soon. So if you happen to have any questions, do submit them, as it's going to be about not more than 15 minutes. So depending on, we've got some flexibility if you guys have to leave soon or if you want to stay longer.
I have time.
I got time.
Okay.
Guys, I am so sad that you ran so hard away from Sunset in Perspective.
What do you want to know?
That was.
What do you want to know?
Oh my gosh. No, don't just keep doing that reset thing. We were in the middle of an argument about it, and you ran away to talk about horizons and curvature.
How did I run from the conversation?
You want me to
about
share
the
my
sun?
screen again and show the diagram again? I'll do it.
It's redundant. I want to answer your question about what you
answer this. This is a diagram that I made.
Your diagram. You want me to answer your specific? Well, ask me.
Yeah. Okay. So this is the evidence.
Okay, show it.
This is the evidence that I collected. Okay, so this is a right here in this bottom left. That's a demonstration of me walking away with a flashlight. This is how perspective would look if the sun was moving away. Notice how the distance between images changes dramatically according to an arctangent function.
That looks good. That does look good.
The sun does not do that. The distance between images is the same during the entire time lapse.
You're showing a curved path in the sky.
Yeah, you're just getting distracted about some nitpicky little detail that is perfectly explained within the globe.
I'm analyzing your information. So don't feel upset if what I'm saying
You're not
is
analyzing properly. That is
an
an epic fail of an analysis.
You're showing that the sun also gets smaller. And then
I told you. I explained very clearly. I was not controlling for size.
So the sun, you're showing two things here that I like that actually prove flat Earth. Two things. The sun gets smaller as it goes away.
It doesn't. That's not what this shows.
Like in what you're showing, it does. In your evidence,
it gets dimmer. It gets dimmer.
Right, in your evidence, you're showing it gets smaller.
I'm showing it get dimmer, but that's not the point.
And you're showing that it has a curved path through the sky, which you agree
as it should be on a globe.
That's fascinating. I disagree with you.
Well, you're just wrong. Try answering my actual evidence.
I'm just wrong. Well, how about you come at me with my evidence? What is the reason that the sun has a circular path in the sky?
Because it's on a celestial sphere.
Me looking at the sky does not affect what the ground is. I said, why does the sun have a circular path through the sky?
Because the sun is on a celestial sphere. What part of that are you not understanding?
So the sun is on a celestial sphere.
Wait a minute. If it's true that the sun takes a circular path in the sky, which sure. Where is the circle centered?
Okay, this very center is the North Pole.
So then why is it in, say, Melbourne or Brisbane, Australia, Why is it that on their summer solstice, the sun appears to rise from the southeast instead of the northeast?
There is such a thing as perspective distortion that exists.
So
I would say
because
Another
of
rescue
look up.
device.
I already told you earlier of that, how to understand that. You have to look at these two specific phenomenon that I mentioned. Anti-crepuscular rays and the analemma.
Both of which shatter the
why is it
flat
that
Earth.
so if the sun is truly on December 21st in Brisbane, the sun is actually to the northeast of the person because it's spinning around the pizza cutter,
Yeah.
right? However,
that's accurate.
What is it? Why is it that they can't look in that direction and see it, and instead they have to turn 90 degrees to the right and look in that direction in order to see it?
I just answered.
No, I'm asking for the mechanism. I'm asking for the mechanism.
It's this. I just told you. It's perspective distortion. It's a
Can you
result
give me
from how
one
we
other
observe.
example?
I gave you two. I said
No, an example of when something is directly in front of you,
You have to
but you can't see
understand what
it.
I'm saying. You have to understand how anti-crepuscular rays are formed.
Anti-crepuscular rays prove that the sun rays are parallel.
No, it's an insufficient answer. Now,
I just want an example of
You're just using a magical rescuing device.
No, I'm explaining it perfectly.
Just to be sure that
it's an
everybody can hear
elegant.
you guys.
But you have to understand how the analemma is made. The analemma is not a result of a theoretical axial tilt. Like I said previously, the stationary position of Polaris and the fixed rotation of stars around it disprove the notion of axial tilt. So, in order to figure out what the analemma is, you have to throw out any idea of axial tilt. You have to look at what the analemma is, the figure 8 pattern of the sun's path through the sky on one time every day.
I can recreate the analemma in 10 minutes using Blender, a 3D computer graphics program, just by modeling a globe. And I did so
do that with practical effects instead of just using a computer model. Can you utilize practical effects?
Globy McGlobeface did that on TikTok
to show in reality what you're saying.
Yeah, Globy McGlobeface did that. He recreated the analemma using practical effects.
Okay, well, we could see it. It'd be interesting because I could show it too. I can describe it. I told you how these two phenomena.
What you're doing is you're saying my magical rescuing device is something I use here, so therefore I use it. I can use it here too, and it's science. That
sounds plausible. That sounds like a law. That sounds like something that works here also works here.
It doesn't work though. It's just a magical rescuing device every time you use it.
You say that, but what is the reason that these two actually fit well? Like they
don't fit well. They just fit well in your mind. It's all in your mind.
And reality. I'm saying reality.
I have a really simple question, and like maybe this is maybe there's some explanation here, but like look. The sun is actually to the person's northeast. If they look northeast, what's stopping them from seeing it?
I told you.
It's just a straight line between them and the sun. Why can't they see it?
Do some experiments with what is called a glass dome magnifier, which
is the sun below the dome or above the dome?
What do you mean dome? Are you talking about firmament
you just said a dome?
No, yeah. What I refer to is our personal observational dome.
I'm just asking. Look, there is a thing
is
there.
Something different. Yeah, the firmament.
There is a thing. Okay, so there is a thing. There's a sun, and you could draw a straight line from my head to the sun if I look northeast while I'm in Brisbane, right? Straight line, doesn't have to curve. You could draw a straight line from my eyes to the sun. Why doesn't the light from the sun get to my eyes?
You have to understand the relational position of where you are.
I'm in Brisbane.
The nature of light and how
it travels in straight lines, roughly.
Like I told you, there are what's called perspective distortions.
Magical rescuing devices.
No, it's not. You can see this. You can see. No, I'm saying you could do this. This is easy. A glass dome magnifier.
So you insert a glass dome, a magical rescuing device that doesn't exist.
Am I standing in glass?
One at a time. No, I do want to
represent
Matthew.
Yeah, they're just being rude. Yeah, they're being rude. They don't want me to answer.
I'll give you a chance to finish.
You're the king of rude.
Glass dome magnifier, the reason that is utilized in these practical effects experiments is that it represents how our perspective works.
Wrong.
I'm
It
not
doesn't.
in glass.
Also, show me how I'm wrong then. Show me.
Well, I'm
No,
not
you're
in
the one
glass.
making the claim. You're the one
It
trying to
matches.
create a
Yeah,
magical rescue
because
device.
it matches.
It's
You
your
just said-
burden.
You
But-
just
but
said
hold on.
it works here and it works here.
No, I
So
was
what does
I was
that mean?
putting
Glass.
words to
Yeah.
what you were saying. You
Yeah,
say
what
it
does that
works
mean?
there.
Let's
You
one
say
at
it
a
works
time.
here. It doesn't.
You're
It
saying
doesn't.
it doesn't.
One
It
at-
works
one
in
at a time.
zero
I
places.
do want to give.
You're
I
just
want to kick it
going,
over to Peter for about 30 to 60 seconds, and then we'll give you a chance to respond, Matthew. We'll give you a chance to explain your whole response, Peter.
All right.
Okay, so what it seems like you misunderstood, like woefully misunderstood what I was saying. I was saying that your argument appears to me to be open quote. I use this rescuing device here, therefore it works here too. End quote. Those are
Incorrect.
that's my paraphrase of your argument.
It's
In
incorrect.
reality, it works in zero places. It's a magical rescuing device that does not exist and works in zero places. Anticorpuscular rays prove a globe. Analemma proves a globe. Sunset proves a globe. Every one of these proves a globe. You just use your magical rescuing device in all of them. Prove your magical rescuing device. Prove to the audience that it's not a magical rescuing device, that it's something real.
This is something people can do themselves, look up for themselves. It's how we perceive reality. You just don't want to accept that.
You just have no
Can I ask
evidence
a-
for it. You have
It's
zero
reality.
evidence.
Stupid question.
It's reality. It's not my magic, and I do not refer
It's
to it
completely
as a
magical.
rescuing
There's no
device.
existence
okay.
to it.
This is
Whether it's magic or not, I do
observational
want to
data.
jump to the next. I think Dr. Blitz had a point or an argument that you want to make. Go ahead, Dr. Blitz.
I mean, we could change topics, but I have a perhaps stupid question.
Thank you.
So, okay, I mean, you agree that the sun is something that emits light, right? Or something.
My
like that.
opinion? You mean my opinion?
Yeah. What's your opinion?
The sun, it's okay. This is my opinion. It's okay to disagree with me. The sun is some type of like 3D projection of light from the other
Okay,
side
cool.
of the firmament.
Cool. Okay. So, but there's like a place where the sun is, right?
Well, there is
Or where that projection
one,
would appear to be.
there's one sun, and that
Yeah,
one
okay.
sun, listen, that one, my idea of it, that one sun is on the other side of the firmament in a medium.
Yeah. Okay. But like, so the only reason I ask is because I'm imagining that I like take a laser, like a really high power laser, and I like, I teleport to where the sun is, and I point it at a person in Brisbane on December 21st. Lasers travel in a straight line, right? Would that laser get to them?
Well, if the laser's light, I wouldn't know how the refraction would take place through the firmament. The sun is a very individual light, just like the moon is a very individual light with its own properties. Now, that's my opinion that it is a projection of light, what we see it like a disk, but it's like a 3D projection of light that emits light in every direction. However, you have to remember how our observational dome will modulate how we perceive celestial phenomena. So there's a lot of factors to incorporate, not just denying it simply as a rescuing device.
It is a rescuing device. You have no evidence. It's incoherent and it contradicts other evidence that you try to present.
In what way is it incoherent?
So the only reason I asked is because
in what way is it incoherent? If that's your
optically
opinion,
and geometrically.
Okay,
Those are the ways
basically,
in which
how
it's
so?
incoherent.
How so?
Basically every other context that we see, like basically every other context, with some very, very slight exceptions, like light travels in straight lines, right? Like you take a laser beam, it goes in a straight line unless you like have it enter water and then it'll bend. But like otherwise, light travels in nearly perfect straight
Actually,
lines.
also, no, our perspective will also warp the path of the lights above us.
The light is just doing whatever it's doing. It doesn't care what our eyes are doing, right? The light either gets to you or not.
Well,
Right,
you're
he thinks light
discounting. You're
photons
discounting.
orbit our
You are
eyes.
discounting how profound our perspective is.
I'm
I
just
think that's
asking
what
whether
you're
the
doing.
light beam gets to you, right?
Light travels. Yeah. Is that
Yeah,
you don't think refraction exists? Are you saying there's no refraction that
He
exists?
literally
didn't
just
say that, but
acknowledged a refraction.
That's cool. That's a cool straw man. But I mean, the point is that it seems like the light from the sun should be able to get to you, regardless of what your eyes are doing or what your brains are doing. The light from the sun should be able to get to you.
But listen, there's also, you have to understand, there are perspective distortions. as a result of our dome of observation. Our
In other
personal
words, your
dome of
magical
observation.
rescuing devices.
No, I think you keep saying that because you have nothing better to say.
James, do you mind if I bring up something else? Something a little bit different? Because this seems to be going
Yeah,
nowhere.
you haven't shown any evidence for anything that you're
You
saying.
can say that if you want. I showed a lot of evidence. And I destroyed everything you
Ready
put
for
up.
you, Dr. Blitz.
Yeah, so and this is just a cute one, and we can talk about gravity more if you want, but this is just cute, and it's something that not a lot of flat earthers know about. Do either Tacori, Matthew, do either of you guys know what the Minos experiment is?
Minos?
Minos, M-I-N-O-S.
Just explain it. Don't ask me about some
I-
obscure paper. Let me
No,
know
it's
what you're
not
talking
an
about.
It's not an obscure paper, but okay. So the Minos experiment is it's a measurement of a type of particle called neutrinos, or rather, it's an experiment involving neutrinos. And one of the weird things about neutrinos is that they pass through basically everything. They'll pass through like concrete. They'll pass through basically anything. They don't do much. They're very hard to detect. But one of the experiments that was done, this is what the Minos experiment is that they wanted to see what the neutrinos do after they travel a very long distance. So they measure the neutrinos nearby where they're made. So they're made in a particle accelerator, and then they measure them nearby, and then they measure them 700 kilometers away, 460 miles or so. The trouble is, in order to make this beam of neutrinos connect the two detectors, the one that's nearby and the one that's far away, they have to aim this beam of neutrinos into the ground. So the neutrinos pass into the ground and then somehow end up again near the surface 700 kilometers away. So strangely, on a flat Earth, the neutrinos are going down into the ground and then curving up. On a globe Earth, they're just passing through the Earth in a straight line, ending up at the other detector. Why would this beam of neutrinos have to point into the ground at like a 3-degree angle in order to be picked up by the other detector? Seems kind of strange.
This is just like this sounds like all suggestion. Like you say,
this is an experiment that was
happens,
done.
watch, you say, if this happens and we can create these things here and we can do this, what is the reason this happens?
No, it actually is happening.
I don't even believe what you're saying. This sounds like you're just making it up, and people.
I can show you the data for it if you want.
I understand that it's official mainstream.
I actually have a friend who worked on this experiment personally.
I understand that the mainstream narrative.
I have a friend who worked on this experiment personally.
Propaganda. They put out all kinds of propaganda to suggest that the Earth is a ball.
So you're saying his friend's personal testimony
Actually, interestingly,
is
that
propaganda?
friend is currently.
I don't care about his friend. Yeah, I don't care about that experiment. I don't care about the suggestions. I don't care about the imaginary the formulas that you have to come up with.
So close eyes and ears and hum.
It's easily it's easily disregardable because it does not apply to anything.
Easily knowable.
So where are these neutrinos? Do you have them with you? Can you show us a picture of them?
Neutrinos don't interact with light, so you can't see them with your eyeballs.
So
the only way to detect them is with very large neutrino detectors, which is what they built near the emitter, and then 760 kilometers away from the emitter, and they had to aim them into the ground in order to detect them 760 kilometers away.
That's what you're suggesting.
No, I'm not suggesting. I'm telling.
You're saying they did that. You're saying they did that. You're saying that just like they
do you want me to show you a picture?
Just like the pictures of the people like walking around on a movie
let me show you,
on the moon, right?
picture.
How they have fake videos of people on the moon.
Why don't you tell us exactly who you think is lying or mistaken here and how?
I think that on the side of people believing the Earth is a globe, utilizing theories and imaginary science, that's the side that's wrong. The side that's correct is that's on the side of
that's not what I asked you.
Reality.
That's
you just literally asked me who's wrong in this situation.
No, I didn't say that.
Told you.
I said who exactly do you think is lying or mistaken and how?
I think
when Blitz is telling you about an experiment that his friend has done.
Yeah, when we have
interacted with
government, when we have a mixture of government and science and money, that's not the correct thing.
How does that work exactly? Tell me details.
Because watch, you want me to believe particles were created in a place I cannot go to, and I cannot even see these things. I have to believe a machine, a highly advanced machine, and the people that operate these I have to believe everything they say.
Yeah, one of whom is Blitz's friend.
I don't care whose friend anyone is. We
Okay,
have to
so
see
you're
these
just
let's see the neutrinos. Let's
sticking
see
your
it.
head in the ground
Let's
and
see
Do
it.
you want me to show
No,
you? Want me
no,
to show you the?
if you
the
want, like, you could show whatever you want, but if
Okay.
you're telling me I have to believe what you're saying, no, I don't.
nobody's
It
telling you
just
you
seems
have
like
to believe anything.
suggestion. It's like it's all
You just look like a
suggestion.
fool when you just nuh-uh it. That's all.
I don't
Let's
care
go
if you
with,
believe that.
instead of
I
talking
disagree
about,
with
okay,
almost everything you said.
we get it, Matthew, that no one can force you to believe something, but we do want to, let's look at the evidence though.
Yeah,
And
let's
Dr.
do
Blitz,
I
it.
can
you
just
wanna
show you a
it again?
picture.
Yeah,
If you
show
Yeah,
it.
let me just show you a thing. I mean, like I could also show you the write-ups and stuff like that, but I don't know if
Let's
that'll
see
be
the
convincing.
best you got.
This is from the beam line. He's down at the bottom of the beam line looking up. So at the top of that hill is level. The beam line is pointing down into the ground. This is a picture that he took from
That
his
looks
phone.
like a tunnel under.
It's a tunnel into the ground. Into the ground. Yeah.
You
Pointed
mean a
down.
tunnel down? Okay.
It's a tunnel down into the ground. And that thing to his right is the tube where the neutrinos are.
You said it's 3 degrees from level, right?
3 degrees. Yeah.
And
57
so
milliradians.
it's just in a tube underground.
Yeah, well, so behind him is concrete, and then the neutrinos go through the concrete to the target 760 kilometers away.
So it's not like a beam traveling through dirt. It's just in a tunnel.
No,
the
it does.
tunnel doesn't extend past the.
No, the tunnel ends behind him, and it
Is
just
that all
goes
you
into the
have?
wall.
Dude, is that all you have?
No,
Just
I
like
can show you
picture of a tunnel?
papers if
I mean,
you want.
Come on,
You want the
dude.
papers too?
Bring it.
You want
show
okay.
something. If you're bringing it up, show something.
Okay.
Hey, when you
Yeah,
get
enjoy
through
that.
your
This is
papers, I'm gonna show
lame.
ours
This is
too.
Yeah, because what you're showing is lame. This idea. Look
Hold
at
on,
this
let me-
picture of a
Enjoy that
tunnel.
sense of that
Believe
relief
my friend.
washing over you that the
Right,
cognitive
right.
dissonance
Hey,
is over.
hey,
Hey,
Believe
James,
my friend.
hey
Believe
James,
my
can I share
friend.
my screen real quick?
Here we go.
Sure. Let's see. First, the one from Dr. Blitz, and then Tacori, I promise you're next.
So this is an engineering document for the Minos detectors. It's a technical design report. This is the thing that I was referring to. You just saw the Fermilab end of that beam line. And so here's the geographical layout of this experiment. The
Okay,
neutrino
can
beam
you
is
pause it real
produced.
quick? Is that
Yeah.
the Earth is that the 700-kilometer line underneath the Earth?
Yeah,
It's
yeah,
not
that's
to scale.
It's not to scale, obviously. It's
Oh
just
my
it's
God,
just it's
dude!
just a
Oh my
picture.
God! Oh my God!
Okay, so
Come
hold on, wait a
Come
minute. If it's not
on,
to scale, then
dude!
that means it's not accurate.
It's not accurate.
It's
How y'all gonna
it's
give
a
us
have the
not to
diagram
scale? You
demonstrating
gotta
a
give us
concept.
up to scale.
It's just a
Hey, let me share my
diagram.
screen real quick, James. Cause this dude is gonna give
Okay.
us a not to scale.
Okay. Whatever you say.
Some things are impossible to show to scale. I don't know if you guys understand that.
So why would you
Dude,
show it anyway if it's never mind. Let me share my
To
screen.
show a concept.
I was
Come
showing you
on.
the
But
path
it's
that it
not
takes, that
accurate.
it's 57 millirads into the ground, etc.
Hey, is my screen sharing?
It is loading, but it is
There's a
still
whole bunch of
showing
public
your
information
screen.
on the Minos experiment, by the way.
Now we can see it.
Propagation of
There we go.
electromagnetic fields over
Here we
flat Earth.
go. Here we go.
The whole documentation. Oh, there's like over 75 documentations of electromagnetic propagation on a flat plane or a dielectric plane. Watch this. Reports look at the interaction of the radiated electromagnetic fields on the Earth's ground in military or law enforcement applications of high-power microwaves (HPM) systems, meaning that this is in your military. Your military is dependent on the flat Earth to
Where does
actually
it say
deal
flat
with
Earth?
this stuff. Let's continue.
Okay.
Let's continue. Watch this. Watch this. Effective military or law enforcement applications of high-power microwaves or HPM systems, in which the HPM systems and the target systems are the near and ground or the water required to the microwave power density on targets to be maximized. The power density at the target for a given source would depend on the destructive and constructive scattering of fields as they propagate to the target. Antennas designed for HPM systems include this whole thing right here actually destroys y'all. Look
Where
at
does it
this
say
right
anything
here.
about a flat Earth?
Earth ideals vertical dipole. Dipoles oriented along the z-axis perpendicular to the ground plane and is addressed to the horizontal dipole to the ground planes that follows. Let me show y'all some more.
Did you just say dipole?
That's how I pronounce it. That's my accent. Don't
Okay.
worry about my accent.
Okay.
Okay, so these are different demonstrations. Figurine 1 or figure 1, geometry for the vertical and horizontal.
Blitz, I just copied the URL for you if you want to look at it yourself.
Thank you.
His resolution was a bit.
And here's and this is another one right here. So you want to pull our documentations, we can pull our documentations too. We can actually pull out over like 400 documentations from the military, from different type of Air Force, from Air Forces all the way to Coast Guard.
First law of FLIRF is every source they try to cite
Let's give 'em a
contradicts their
chance.
claims.
Give you a chance to
First
respond.
of no, you want to know the
finish the story?
craziest thing about it? These are from y'all agencies.
Yeah,
Why
they
did they-
probably contradict your
These are
claims.
from y'all
Hey, you
agencies
should-
that
you
doing
should-
that's
You should look at page 23 of that
electromagnetic
document.
forces and using
You
a
should-
flat Earth model to do it.
You should look at page 23 of that document, by the way.
So here's the thing: we saying that these are from your
Tacori,
what they doing
can
this
you go to
stuff
page
on the
23 of
flat
that
plane.
document, please?
I pull up page 23.
Okay. Do you see the word? Oh, no, I'm sorry. I'm an idiot. I was reading something. I'm dumb. Never mind. Ignore me.
Cool. Don't worry.
I was
So-
just being an idiot. I thought that there was a constant defined, but it was. it was
Oh,
a
we
different
got
kind of
other
constant.
we got other different type of documentations. So
But where
other
does
than
it say
that,
that the Earth
we
is
was
flat
just-
in this document? I'm sorry.
I was just what'd you say?
Where does it say the Earth is flat here?
Okay, so what would you say if I show you where it say flat Earth at?
Well, no. Where does it say the Earth is actually flat?
Just the phrase
The
flat
title.
Earth in the title isn't good enough.
The literal title. Let me show you again. Let me
Yeah,
show
No,
that's
but
you.
not
where
good
does it say
enough.
the Earth
Yeah,
is
it's literally
actually flat,
called
not just
flat
how it
Earth,
works?
right?
Huh?
I was
Now
gonna
it's not
mention
good
that.
enough now. Now it's
Well, no,
not
I mean,
good enough
like,
now.
it
The
even
title
says-
is not good. The title
it even
is
says
what
that the Earth is
summarizes
being
what you're gonna see
idealized.
in the documentation.
It literally says, but near the
Why would they
surface of a
false? Why
flat
would they put some
idealized
false in
Earth.
documentation?
In
Look,
fact, the paragraph that you
propaganda
One
of
sec, one sec, just because
electromagnetic
there's-
fields over flat Earth.
Yeah,
But
look, it's in the,
the
title.
paragraph that you read,
Where does it
the
say
paragraph that
flat
you
Earth?
read-
In
one
the
sec,
title.
one at a time. One at a time.
the
Look,
Go
paragraph
ahead,
that
Flat
you
Dr.
read,
Blitz.
it's
I
right
think Dr.
there.
Blitz was trying to respond. We heard from you, Tacori, then we heard from Matthew. Let's give Dr. Blitz.
can you
a
go
chance
back to
respond.
page 7, Tacori, and then we can just look at it together? Yeah, right there. See how it says, wait, sorry, I might be looking at a different, I'm sorry, you should be at the introduction, which I guess is, scroll, I guess it's a little bit further down.
Bro, this kills you, bro. It ain't nothing. Look at this
No,
right
no,
here.
just
Page
please-
7, comparison principle fields
Can you
for the
please-
ideal I'm gonna say dipole.
Wait, is this the
Oriented
same document?
perpendicular and
Can you please
horizontal
scroll down?
to a
One sec.
homogeneous flat Earth.
Can you please scroll
There
Right
down?
it is.
there.
There it is.
Can you please
Page
scroll
Okay,
down?
let's hold on.
It's-
Just all right, relax. Take a deep breath.
There.
Let's
It's
Introduction,
page
right here.
one person
7
at
in
a
the
time.
PDF. It's marked as page 1.
Look
When
at
I say
this.
take a
Look
deep
at this
breath,
right
that
here. Hold on,
doesn't.
wait a
you
minute.
guys-
Look at this
man,
right
I
here.
hate to say
It is
this, but I'm
assumed
just
that
gonna-
the transition in
Can I
Can I
antennas.
finish what I was
Hold
saying,
on.
please?
Can I read
Tacori,
this?
I was trying to say
Okay.
something, and then you interrupt.
Sorry, I'm muting everybody just because when I say take a deep breath, it doesn't mean talk. Interrupt me while I'm saying. I'm just trying to. If everybody's talking over each other, then we can't hear anybody. So we'll go with Dr. Blitz for like 30 to 60 seconds without him being interrupted by anything. And Dr. Blitz, one sec,
Oh.
and I'll unmute you. And then
The
we'll go to the next person. But just to have a little bit of order.
the screen went away, which I needed. I'll share it though. Sorry. The point I wanted to mention is that in this introduction, it explicitly says they're talking about the surface of a flat, idealized Earth. That doesn't say anything about it being that this is actually the shape of the Earth. They're just analyzing what it would be like over an idealized Earth. That's all.
That's exactly what it's talking about. That's why it says a flat, idealized Earth. Why is they giving an ideal of a flat Earth for electromagnetic
Because
propaganda
locally it
if the
approximates.
One
flat
sec,
Earth didn't
one sec.
exist?
If you want to finish, go ahead to Corey, and then we'll give you a chance to respond. I don't blame you, Peter. I know that he asked a question, so you're wanting to answer. But go ahead to
That's why
Corey.
I
I'll give you a
said
chance to
flat,
finish.
idealized Earth.
Okay, Peter.
It's because on a globe, locally it approximates a flat surface. That's why Matthew Hakim's evidence, when he was just standing on a hill, it still looked flat, because that's not how you detect a
So
globe.
listen, you
It
still
locally
using
looks
a
flat.
flat Earth through perspective for the. You still using a perspective. You just said it. You said because it has a flat perspective or it seems flat. So that means by default this
Locally.
will work on a flat Earth.
Locally, a flat surface and a globe surface locally will begin to approximate one another. They converge to each other as you get smaller and smaller and smaller on the globe. We are very, very tiny in relation to the globe. It is 8,000 miles in diameter. That's
Listen, here's
huge.
the thing. Here's the thing. Because you're literally saying that the reason is just happening because you need a flat Earth ideology, flat Earth concept.
No, it's not
your
needed.
globe.
It's just
Yes, you
easier
said because
sometimes.
we are so small, it looks flat.
It's
That's
just
why it works
easier
on that.
sometimes to pretend it's flat for the math.
Hold on,
That's what this
but
is
it's
saying.
not real. But hold on, why would it be easier to pretend it's flat for this electromagnetic propaganda to work? Yeah, propaganda to work if the Earth ain't flat. Why would
Because
they need
of
to
how
imagine
math
something
work. Go
that's
try
false
doing
or
some
not
math.
scientific?
Go try
something
doing
that's
some
supposed to
math
be
and you will
scientific?
understand.
Differential geometry and curvilinear coordinates is hard, actually, it turns out.
Yeah.
Hey, Peter, Blitz, you're cooked. You just got cooked.
No. Don't play referee. You're just looking like a fool.
Now, listen.
You
Don't
did.
make me pull out another one.
Oh
Now it's
no!
best you. Now it's best you.
I'm sure you could pull them
Hey,
out
I'm
all
joking with
day.
y'all. I'm joking with y'all.
So-
but
Sources that contradict what you're claiming, which
So-
is
no, it does not contradict what I'm
it
claiming.
does.
Listen,
does.
So, okay.
you went
let's-
to the area, and all you showed was a flat idealized Earth, and you say that contradicts my argument.
No, we understand math language. Okay, they say that they simplify the math by making certain idealized assumptions that are not corresponding with reality because the effect is marginal. The effect
So
on the
hold on,
math
wait a
is
minute.
marginal.
Let me get something straight. So you're saying that they're using pseudoscience because you would call it
Nope.
flat Earth pseudoscience.
It's not pseudoscience. It's just
I'm saying
simplified
you would
math.
call because you said that they're because it's saying that they're using an ideal of a flat Earth. You say it's pseudoscience,
No,
which
I
means
didn't
it's
say
fake
that.
science.
I didn't say that.
It's
So
a
you saying
good
flat Earth ain't fake
approximation
science?
over sufficiently short distances.
Yeah, a good approximation over sufficiently short distances. Exactly what Blitz said.
Yeah, and a
What are the
short distance.
distances that
How
they're
would it look
mentioning?
at a short distance? Would it look flat or would it look curved?
What?
With this short distance that y'all talk about, would the surface look flat or curved?
The shorter the distance, the more flat it looks.
Oh, so it looks flat. So at the end of the day,
Yeah, at short distances, it looks flat. Yeah.
Using a flat surface, or you have to use something that seems like it's a flat surface for this electromagnetic field to work.
No,
At the
you
end of
could
the day.
do it.
So
Tacori,
no matter how you have to
Tacori,
do
can
it,
I answer?
I'm
Can I answer,
almost
Tacori?
finished. Just 5 seconds. Just 5
Okay.
seconds. No matter what you do, you still gonna have to go back to flat Earth. You just gonna have. You ain't got no choice.
So
Now
you don't have to. You absolutely could do. You could do the mathematics in the full generality. of a
If you
curved
liked
surface.
pain for no reason.
Yeah, this is something that like I had to do as a grad student that you do in like a differential geometry class. It's miserable. You can do it, but it's miserable, and it doesn't give you significantly more precision than if you had just worked in a in a small neighborhood and just assumed it was flat. Like if you did that, you'd be slightly off, but not in a measurable way.
Which if
what
you
you're
had done
saying
any
is it's
engineering math,
miserable
Tacori,
to
you would
learn
know.
globe theory, right? What you're saying is it's miserable to learn that.
No.
Well, the math is
It's
better,
miserable to
turns out.
do
reality.
extremely complicated math for no reason for a marginally improved precision.
And then a better question is, at what point does the Earth become a globe? If it's flat locally,
It's a
at
globe
what
the
point
whole
does
way.
it? At what point? No, you just said
I'm
it's
just
flat
trying to
on a
understand
small
why they didn't
area.
assume a
At what
globe
point
for
does
the
this
the Earth become a globe?
electromagnetic
second.
It
field.
One at
looks
a time,
closer to
gentlemen.
flat over smaller distances. The
So at
smaller
what
the distance,
point
the
does
closer it looks to flat.
Yeah, so at what point does the Earth become a globe?
It's
It's
a globe
not
the whole
only an
time.
imagination. No,
It's a
you
globe the whole
just said
time.
it's flat. It looks flat.
No, I said it
close
looks
by,
flat.
right?
It looks approximately flat at
okay.
small distances.
Okay, like I said, at what point does the Earth look like a globe?
Oh, you're asking at what point can you actually like at what point does the curvature become significant? Is that what you're asking?
At what point do we see curvature?
Oh, you want like a height or?
Yeah, I want you to attempt to contradict my video, which showed Southern California is flat.
So I have a study from I think an optical physicist that I can bring up if you'd like, where he showed that with a camera from 35,000 feet, he was able to detect curvature.
Okay, and like was
I can
that
show
on
you
a
that.
balloon? Was that on a
No,
balloon?
it was on a commercial airplane actually.
Okay, taking a
I
picture
also
through
have
the
a personal
window.
friend who
Yes.
I
Taking a
helped.
picture through the windows. That doesn't help. That
Why
doesn't
not?
help with bowed
Why not?
windows because the window is circular.
The shape of the window doesn't affect what you
Yeah,
see
no,
out
it
the
does.
window.
How you? Yes, it
Oh,
will
can you
modulate
show me how that works?
It will
Can you show me how that
modulate how you
works?
perceive. It will modulate how you perceive reality, similar to
You
how
using the word
glasses on your
modulate
face.
doesn't
show me how
match
that
what
Hey,
you're
works?
don't
saying.
interrupt me. Don't interrupt me. It
I
will
just want you to show me how that
modulate.
works.
Stop interrupting me. It will modulate your perception of reality, similar to how the glasses on your face will modulate your perspective of your surroundings and make it clear.
They make these a specific shape in order
Yeah,
to do
exactly,
that.
exactly.
Plain windows
right?
are flat.
You know that.
Well,
so
not
Matthew,
always,
to be
not
clear,
always.
to be clear, you know that if I had square glasses, things would look the same, right?
It just depends on how they're made. There's a
It
lot of
depends on their
factors. There's a lot of factors.
It depends on their
There's
curvature
factors.
in this direction, not
Well, that
in
too.
this direction.
And what kind of
No,
lens
the
the
actual
camera
shape.
was using, right?
The shape of the lens
Depends on
doesn't
what
matter.
kind of lens the camera was using, because even using a normal camera, you can make
I'm aware.
distortion.
They accounted for this.
Listen, using a normal camera, you can make it distort where it
I'm
looks
aware.
like there is curvature,
accounted for
or
this.
where the Earth looks like this. You
They
can make
accounted
the
for
Earth
this.
look like this
They accounted
using
for
a
this.
normal camera.
Yep, it's
right?
called barrel distortion, and they accounted for that.
Yes. Now, when you have the lens of the camera going through another lens, it will
Not a
cause
lens.
distortion.
The window is not a lens.
It will cause distortion. Even
No.
water, looking through water, will cause distortion.
So
Yeah,
to be clear, you're just saying "nuh-uh" to my answer of 35,000 feet with a camera is good enough.
Incorrect. I gave you an elegant response that you're just not.
No, that was not elegant.
Your response is that the windows
looking through a medium
pane of
will
glass.
change it. Looking through a medium will
It
change
actually
it.
won't. If
right?
your pane of glass is vertical, it won't.
Looking through a medium will change it.
Yeah, so the
Interestingly
other thing
enough,
you can
thin
deny it
lenses-
if you want to.
I mean,
but
I've
that's
taught
how it is.
optics. I've taught optics. I can tell you how.
I think
I
we're just about to
appreciate
make the
that.
same
I
point.
appreciate
distortion.
that.
One sec.
I appreciate that. So let's
Okay.
explore that then.
Yeah. So if you have a pane of plastic, say that's what these windows are made out of, right? If you have a pane of plastic, if you want that pane of plastic to cause distortion, you need to have one side of the pane of plastic be curved in a different way than the other side. Now, because the pane of plastic, the window, in an airplane it's fairly thin, right? It's like, that thick or something. There's two panes, but
Well, it depends.
well, they're not that thick, right?
They're not
like
all the
yay
same.
thin.
I've been on a lot of planes. Most of them are as Blitz describes.
But they're not all the same.
They're really not that thick. There's an outside pane, and then there's a gap, and then there's the inside pane. But regardless, they're fairly thin. They're not like this thick, right? Anyway, so in order to have distortion, in order to have a lensing effect, you would have to have that one side is curved more than the other side. Like if one side is flat and the other side is curved like this, that would be what you would call a hemispherical magnifier, right? But
No,
on an
I don't
airplane,
use that term.
Okay, well, didn't you talk about like the
A glass dome magnifier, which represents our perspective.
Sure. Anyway, but that's what would happen. However, on an airplane, the inside and outside walls of the pane of plastic are the same. They move in the same direction. One's not more curved than the other, so you're not going to see any sort of distortion effect.
Yeah, but you got to admit the fuselage of a plane is also circular. So
it doesn't matter as long as the curves are the same.
The window on a circular plane, right?
It doesn't matter as long as they're curved in the same way. It actually doesn't matter.
Dude, you're spiraling here. I appreciate.
I can pull up a textbook.
I appreciate the attempts, but you got to understand how.
You want me to pull up my lecture notes from a few years ago
how our perspective works?
Yeah, I'll do that.
It does make things appear circular.
More magical rescuing devices.
No, it's not.
Let me just pull up my lecture notes.
A millimeter wide window.
It is
a millimeter thick window pane is not going to cause distortion.
The Q&A in about 8 minutes.
But you got to understand it, and going through any medium or lens will change it, maybe a little bit. That's the thing. We got to know more
Yeah,
specifics
a
about
negligible amount. You got to be able to know what's
example.
negligible and what's not.
Well, any example given, it should be studied. Any example should, I mean, to find out the truth, right? We
You
would need
should-
multiple
You can look at it
information
and
points,
tell that it's
multiple information.
One at a time, gentlemen. I
You-
want to give you one thing I think that oftentimes I like your guys' tenacity, but just to be sure that no side goes too long is Matthew, if you're able to concisely wrap up your point, and then we'll hand it over to Peter. So Peter or Matthew, just to be sure that you're not going too long, I'll give you maybe another 20 seconds to wrap up.
Okay, yeah, taking a picture, there can be many perspective distortions, especially when taking a picture through another lens. That's basically it. And I know that the airplane window is maybe not many inches wide, but anything can cause distortions. And you have to admit that the fuselage of a plane is rounded. So
Gotcha.
the windows
That's
aren't
about
just
20
going to be
seconds.
like a flat square. It's going to be with the body of the fuselage. That's it.
Go ahead, Peter.
A real engineer or a real scientist can look at each individual factor of a situation and be able to discern whether they're negligible or not.
Can I show the factors that would be in play here?
Yes.
Okay. I just pulled up my lecture notes from a few years ago. Yeah, so these are my notes that I was using when I was lecturing on the subject. We're talking about a lens that looks something like this. That's what we're referring to. It's curved on both sides, perhaps, because it's curving in the same direction. Now, importantly, we have R1 and R2. Those are the rate at which these curve. Those are the numbers that we plug in into the lens maker's equation, which is precisely the equation that we need in order to figure out the focusing effect. Now, if R1 and R2 are the same, meaning that they curve at the same rate because they're both, they're both curving at the same rate of the fuselage, then you have 0 on the right-hand side, 1 over R1 minus 1 over itself, because R1 and R2 are the same, you get 0, which means that the only lensing effect that you would have a focal length of infinity meters. A focal length of infinity means no lensing effect at all. Shorter focal lengths have stronger lensing effects, longer focal lengths have weaker lensing effects. An infinite focal length has no lensing effect whatsoever. So even if they were both curved in the same direction, there'd be no lensing effect whatsoever.
Okay, you say that, but once again, I mean, we're talking about taking a picture through a window, through a
You
round
can look at the window and tell it's
right?
negligible.
Not only a round window, but a curved fuselage side. That's all I'm saying. We would have to learn more about
It's negligible.
Specific example.
It's negligible. You can look at it and tell.
If you see the curvature from that height, well, let's see it again. Let's see this material you're saying and determine for ourselves if it's actually real or just more, propaganda.
You could do it yourself.
More imaginary play. Because I've been up in a big plane, and when I flew to Alaska, it looked flat. The ground looks flat.
I can share with you the paper, and then you can recreate it and see if you can do it. Yeah.
Well, I don't want to do your homework. Sorry.
I mean, you're the one who
do your homework. Do your variables, right? Your variables, your formula to get the answer you're looking for.
Yeah, you don't like real science methodology.
That's the mistake scientists have made, taking the money rather than taking a stand and saying, maybe this is wrong. And we know that scientists should have stood up and said what the government is doing was wrong. They got the money.
If what I just showed you, if what I just linked into the chat is wrong, you could publish a paper and you could change the world.
Dude, I'm probably not even going to waste time. I don't have a calculator brain. I don't care
because you don't like doing science. You're a pseudoscience
reality. No, not every.
Like I said,
a lot of
you're a science denier.
That are incorrect. Your accusations are incorrect.
Like I said in my introduction, being a flat earther is fundamentally anti-scientific.
Yeah, that's your opinion, and I disagree with you.
No, it's been demonstrated here for the audience.
Big time. Yeah, big time. Because we're talking about a picture through a window of curvature you say exists.
Corey, do you have any last thoughts? We haven't heard from you for a while. Before we go to the Q&A.
What'd you say?
Do you have any last thoughts before we go into the Q&A? We haven't heard from you in a while.
I say all I needed to say, but nah. We go to the Q&A.
You got it. Thanks very much for your questions, folks. We're going to jump right into it. And I want to remind you, if you want to submit a question, you can either via live chat, tagging me with @ModernDayDebate. Otherwise, you can push your question to the very top of the list with a super chat. And I want to remind you, folks, actually, I don't think I had mentioned this yet. At the bottom right of your screen, we're very excited to share that Destiny and John Doyle will be debating Trump or Harris, who is best for America's future. It's going to be in person at Penn State. Modern Day Debate is collaborating with Uncensored America. You can get tickets in the description box below. There is a free option. This is a unique one where they've got a lot of support from the university to put this debate on. We're collaborating with them. There are free tickets, so do check out that link in the description box if you're anywhere near Penn State. In fact, anywhere in all of Pennsylvania, you don't want to miss it. It's going to be an epic debate. And we're going to jump into it. Thank you very much for your question. This one first coming in from Free Palestine says, okay, you got that. Want to remind you folks, don't want any super chats that insult anybody or that are off topic. They say, try tracing the analemma with Polaris fixed above the Earth in the globe model. Welcome to the center of the whole universe. Earth is seriously flat. What are your guys' thoughts?
It's false.
I don't know what they're trying to apply.
I
here.
actually tried to recreate the analemma using a flat Earth model, as I understand it. I was trying to steel man, and maybe I was doing something wrong. Then maybe a flat Earther could help me sometime, but I could not do it. I could not recreate it because you have to somehow explain a difference in the. You'd have to somehow explain why there would be a difference in the sun's azimuth at different times of year, depending on like the difference between mean solar time and actual solar time. And there's no explanation that I've ever heard. The fact that the Tropic of Capricorn is larger than the Tropic of Cancer, that doesn't do it. It just doesn't. However, explaining the analemma on a globe is trivial. I literally accidentally discovered it myself by modeling a planet in a solar system. I have a YouTube video about it, or a video on my TikTok as well, and it's like 2 minutes long. Just go look. It's so trivial. I even link to a Blender scene file that's available on my Google Drive where you can look at it yourself. It's trivial to explain on a globe, impossible to explain on a flat Earth, as far as I've seen.
You got it. Spark 344 says, Matthew, you are
Wait.
incorrect.
May I
They
respond?
said, well,
May I
we'll give you a chance to respond to this one because it's actually addressing you. They say, Matthew, you are a liar. Fight the Flat Earth would never use 8"/miles. He always corrects flurfs on this, as that equation leaves out observer heights.
check the debate with he and I. It took a long time for me to get it out of him because he was trying to wriggle away. He eventually told me that.
This
But I
one
want to
from-
address the previous super chat first. Now,
we do have so many questions that I do want to limit it, unless it's I can give you a really pithy response, but I do
really
want to
quick,
limit
I'm not going to say a
rebuttals.
jerk thing.
Hold
I'm
on.
not,
Well, I don't know. I don't see how you don't understand. Like if someone's mid-sentence, that's not a good time to just start talking. Is that I want to give you a quick and pithy response, but I do want to limit the rebuttals during the Q&A just because we do have a lot of questions that we want to get to.
okay, just really quick response. The chatter was trying to underscore the significance of the stationary position of Polaris and the fixed rotation of the stars around it with the idea of the analemma, to compare those two ideas. And now we know that there is no axial tilt because of Polaris,
False.
leaving the answer of the analemma being a result of perspective distortion.
Also false, incoherent. The Polaris is stationary because it's near the axial pole. That does not disprove the axial tilt. That's completely false.
So you admit Polaris is stationary.
It's pretty close.
So how is there axial tilt if Polaris is stationary?
How does that have anything to do with anything?
It's
Polaris just
directly
happens to
related. It is
be
directly related. It
How
is
does-
directly related.
Polaris just happens to be very close to the axis.
You're still not
Hey
understanding.
James, I'm trying to
You're not
log on
understanding the
this
point.
one.
Tacori, yes. What did you say? Tacori, are you there?
Suddenly there's two Tacoris.
There
In
are
my
me.
Yeah, I was saying that I was trying to My bad. I was saying that I was trying to log out on my laptop and get back on my computer. On my phone.
All right, we've got you in here, and I just adjusted the screen. Any last thoughts on that last question? Otherwise, we'll jump into the next one from TR. Says, does Matthew get bonus points if he can fit as many buzzwords into a non-answer as possible? Ooh, how do you like?
I like that because at least they're catching it. They're catching what I'm saying, even though it's a rude remark. They're at least like, oh, this guy's saying some buzzwords. So I like it. Thank you, Super Chat.
And Ooby Doob, thanks for subscribing. I just saw that pop up on the bottom right of the screen. Rark says, for Dr. Blitz, was it the video of a waving flag? I don't know. This is from early in the debate.
Yeah, no. It was a video of a jumping man. Sorry, it was a jumping man in a video with a waving flag.
You got it. This one coming in from, do appreciate it, TR. We got that. Bobby Johnson says, great stream, guys. All credit to our speakers who are linked in the description box. Folks, highly encourage you, if you're listening via live or afterward on YouTube or via the podcast, we put all of our guest links in the description box if they have a link for their channel. This one coming in from Even Lord says, I believe the flat earthers can be more successful arguing their ideas if they go to an English language teacher. Okay, let's see. Ramen or Wheeze says, it's equinox time, flatties. Care to explain why the sun appears to rise due east and set due west everywhere on your fake pizza world? Go.
May I take this one? Okay, yes. I did a demonstration of this on my YouTube. Okay, I have a glass dome magnifier which represents our perspective. I had a flashlight to my right, and I had it on a flat wood board, and I had the line coming straight to me to represent how observation would work along one longitude line. And wouldn't you know the results of that? The light goes directly to the glass dome magnifier when I raise it and lower it, indicating that it would be a 90-degree sunrise possible on a flat Earth. That's what I was showing, or Tacori showed earlier when I wanted to show that video. That's what I was demonstrating with practical effects, how a 90-degree sunrise would be possible for a multitude of people along one longitude line during the equinox. That's it.
This one coming in from, do appreciate it, Even Lord says, question for the debaters, do they believe that WW2 Germans have an Antarctic base under the ice?
Question.
That I have to do research on that. I never heard that before.
Matthew?
I would say just the official narrative involves a huge military operation to a point in Antarctica. So I don't have any information about a Nazi base, but it is possible that governments were doing things for a long time out there.
Careful of those words that might flag the stream.
Oh yeah,
Anybody
sorry
else
about
believe in this alleged base?
No.
This one coming in from, do appreciate it. Bear with me as this just loads up. Ramen, or we got that one. Wholesome Joe says, does either side have an opinion on Terrence Howard and his revolutionary theories, such as 1 × 1 = 2, or wave conjugations to control all matter?
See Flat Earth Dave's, or I'm sorry, see Professor Dave's complete destruction of him.
Don't chill him. I made a video on YouTube that has like 150,000 views.
Oh, I'm sorry.
Him. I beat him to it too.
I'm sorry.
So go watch that. Go watch that.
I didn't see that one. Yes. Please watch Blitz's instead.
From I Killed Earl says, please explain to Matthew that his video doesn't show curve because he's at a fixed point. He's only going to see as far as his vision will allow, which is too short to see any curve at any direction.
Which is true. There is no curvature. So that chatter in their arrogance actually proved my point. Thank you.
You got it. This one coming from Econo NYC, thanks for your question, says, when driving towards a mountain, do you see the top or the bottom first? What's closer, the top or the bottom? What part is bigger? I think that's for you flat Earth guys.
Well, the bottom would be covered by whatever's at the surface on the bottom, like what trees, buildings, anything. That's why we wouldn't see the bottom of a mountain, probably at any distance, unless you were like directly at the bottom of it. The further away it gets, the smaller it's going to look, right? So there's going to be things in the foreground that could block it. Like if a mountain was really far away and someone just put a box in front of my vision, I would not be able to see that mountain. And it's not because it's going around a curve, it's just there's things blocking what I'm seeing. That's why I wouldn't be able to see the bottom of a mountain very far away, because there are things at the bottom, the surface level. That's it.
Did you just say that something is obstructing the bottom of the mountain?
Yeah, I gave the example of buildings, trees, anything.
Ground, like hills, maybe?
Hills exist.
Yeah, like a really big hill. Really big round bulge almost.
If it existed like a
8
hill,
inches per mile squared hill.
That 8 inches per mile is non-existent though, so it cannot be considered a realistic example to say the ground. But if we want to say like, yeah, there's trees, buildings, other hills, cars, it'll block our vision of a huge mountain really far away. And you got to remember, when something is far away, it will look smaller. It won't be small, it will just look smaller the further away it is. So something, yeah, like a small hill or a building or a couple trees could block something. That's it.
I mean, that's not what the question was, but
yeah, it literally was. You said, how is it possible? How do you not see something at the bottom of a mountain? I literally answered your question and you just shrugged it off. Thank you.
This one from Joshua Jamie says, Dr. Blitz said the atmosphere is moving with the Earth. Tacori responded, quote, if the atmosphere is moving over the Earth, it would cause severe damage, unquote. And then said he purposely does not listen so he can bastardize the argument. Tacori, are you going to take that?
Man, it ain't my fault. It ain't my fault this man don't know math or this he don't have no logic. Fam, if the earth is spinning at 1,000 miles an hour, and if the wind is moving with the earth at the same speed, I mean, I don't know, the wind would be moving at 1,000 miles an hour if they moving at the same speed. Come on. This is why I do not respond to certain things, because that's just like them saying if two people if two people are racing and they hit the finish line at the same time, one is gonna be moving faster than the other. No, they're gonna be moving the same miles an hour if they hit the finish line at the same time. The darn earth is spinning at 1,000 miles an hour and the wind is spinning with the earth at 1,000 miles an hour. The wind is moving at 1,000 miles an hour, and I'm in Houston right now, and wind is only moving at 1 mile an hour.
You got it. This one coming in from, do appreciate it, Middle East Witness says, for Matthew, why are they hiding that the Earth is flat? Like, why is this a government cover-up from all the governments?
It's a very interesting question that really the individual has to answer. I mean, I could tell you my opinion, but that is one of the best questions. Like, what is the reason they're lying? And for me, my opinion, Satan has always lied to the people. The job of Satan was to just lie and kill humanity. And everything is a lie that's coming down from this religious, scientific cult that seems to be embedded with the governments of the earth.
If the job of Satan was always to kill humanity, then why in C.S. Lewis's Screwtape Letters was the demon angry that the guy died?
Are you talking about fictional characters?
Yeah, I am.
I don't need to entertain that question.
You don't like C.S. Lewis's Screwtape Letters? It's a good book. You should read it.
I've never read that, but
you really should.
I'm not talking about nonfiction, right? I mean,
you should read it. It's good.
Possibly.
Any last questions? Let me just double check and see if we have any in the chat. Otherwise, we're actually move pretty quick through these. Wholesome Joe said, Matthew and others, what are your thoughts on the Flat Earth documentary where they showed a light at a distance and the light showed elevated at the far end due to the Earth's curve?
I'm not sure exactly is that referring to like globe busters and Jeranism and the
No,
shill
it's referring to
production going on with
well,
that.
it was a Netflix documentary.
Beyond the Curve,
And
yeah.
it was, that
Listen,
one. Yeah.
Okay, my response is Netflix science fiction movies are not proof.
I don't appreciate the slight against Jaren. He's the only one of you who's shown any bravery.
Well, that's what you say. I disagree with you there. We can disagree on that too.
I guess so.
Any last
Home
thoughts?
Depot Earth. You see what Jaren said about Home Depot Earth? It's ridiculous. He's never going to recover from that.
Only one
Check
with
it out.
bravery.
Check it out. Hey, did you see that Home Depot Earth? It's ridiculous. He's never going to recover from that.
Any last thoughts from you guys today as we think we've gotten to the end of our question list?
I actually do have a. I don't know if I was going to use this for my outro. I actually think it's very tragic in a way. Like, this was coming to my mind when we were talking about gravity. When I first encountered flat Earth and I was first trying to debunk it, you can go back to my very first video on it in 2019. I was trying to steel man the flat Earth argument about gravity. And you can see in my 2019 video that I produced a steelman version of gravity for flat earthers. And it's so tragic to me that they don't use that. Instead, the argument you guys are using is so much worse. I made a steelman that was better than your gravity argument.
You're upset we don't look at you as a leader?
No, I'm just sad that you guys aren't using a more logical argument.
You mean like utilizing observational reality?
How you think we feel? How you think we feel when you about your logic against? I mean, about the Earth moving, about the motion of the Earth moving. I have some better ideas for y'all, but
I'm just saying,
I
like
guess,
the argument.
Y'all hold on, wait a minute. I guess because y'all in college, y'all ain't gonna
I'm not in college.
Take those ideas. Oh, okay. Well, I thought y'all was. That was my assumption.
I graduated 10 years ago.
Oh yeah. Well, that's even better because you graduated 10 years ago and 9 years ago. Y'all graduated 10 and 9 years ago. Y'all. Oh, we ain't got to take nothing from you who's in college right now. Get out of college. Well, shoot, you should have had a better argument for the motion of the Earth because that was my 4-year-old even have more logic than that. So
yeah. So what I was saying about gravity though is, if you guys were saying that there is a force applied downward to all objects and that down is down and that's just absolute, that would be so much more coherent scientifically. But instead you're trying to attach it to like electromagnetism or, you know, density or whatever, and those are not scientific.
So you want to disregard known scientific principles such as density, buoyancy, you want to disregard that. Excuse me? I was responding to the previous statement when I said that he wants us to disregard known scientific principles in order to believe a theory.
No, I just want you to stop abusing known scientific principles.
Right? And I don't want to think any of that's irrelevant. I think we should look at all the facts.
I just want you to stop abusing known scientific principles.
How so?
Question.
Listen, I don't attach things. Oh, my bad. Go ahead.
This one from Wholesome Joe says, thoughts on the trip to the 24-hour sun this year?
Who, Globers first?
Man,
that's for the Globers.
No, it's for you guys.
Yeah, we kind of touched on it for a moment with Jaren.
Yeah, I already said it before. Netflix science fiction movies are not proof.
Oh,
this isn't a Netflix thing.
Matthew, this is not.
The Final Experiment, Antarctica, Will Duffy, Jarenism, Buddy. Yeah, it's not proof of anything.
That has nothing to do with Netflix documentaries. They're not even making a documentary.
Well, you say that.
This one from.
But we know what Jaren was involved with previously. We know what he was involved with previously, and now it's like following a pattern.
All right. So forget them. Forget them. What do you think is in Antarctica? Is there a 24-hour sun there in the summer or not?
Personally, I've never been there, but my opinion would be there is only one sun, and its movement, its annual cyclical movement, can be tracked by the subsolar point moving from tropic to tropic throughout the year.
Would you
So-
see the sun for 24 hours on December 21st
In the
Where would I
Antarctica
be?
Circle.
in Antarctica?
I don't think it would be there, but I definitely would not trust Jaron or any of those teams and the people known haters of flat Earth trying to make some kind of documentary to prove something. I don't.
They're not
trust
making a
anything
documentary.
they say.
They're not
I find
I
it
don't
making a
trust
hilarious.
documentary.
anything they say. Yeah, I
I
don't
find
trust.
it funny when you guys eat your own.
Excuse
This
me.
one from
Excuse me.
Wholesome,
I
Wholesome
find it
again?
funny
Joe.
when you eat your own.
Wholesome Joe says, Matthew, run. The
I
police
disagree.
are here. And this one coming in from MMA. Let me see. Where did I just lost this? They said MMA fighter ratings. Thanks so much. Said, Matthew, is there any empirical evidence of the firmament?
There's videographic evidence of rockets. Looks like they're scraping the firmament. That's why those videos look like that. They're cool. Check them out.
Stuart
SpaceX.
James says, tell Matt to please pull back from camera. Look like MODOK. What is that?
MODOK. Oh,
Is that
from Marvel. Mental organism designed only for killing.
This one from Middle East Witness says, Matthew, how do you know? They said you said that Satan wants to deceive people through the globe Earth, and they're saying, but how do you know that's what Satan wants? Like, how do you know? How do you read Satan's mind to know that? Is what they're saying.
You got to have pattern recognition skills. You have to have historical knowledge. You have to have biblical knowledge. When you have that, you can see very clearly what has been happening on the earth.
You don't have biblical knowledge.
You say so, but we can.
You
have
haven't
another
shown any
discussion about
here.
that later.
You
I
haven't shown
mentioned
any
Psalm
here.
19. We could talk about Psalm 19. You want to bring
Yeah,
that up?
we
could
would
talk
have to
about it.
sometime.
You want to bring it up? Bring it up. Pull it
This one
up.
from Stuart
Can I-
James.
Can I just mention how I know I might be in the minority here, but when I asked for textbooks that is empirically demonstrable, you're like, nah. But the Bible, that's a good book.
It's an interesting book of history, knowledge, agriculture, warfare. There's a lot in the Bible. And I will admit, I'm a Christian. I admit that the Bible has been manipulated. Which is
I'm gonna tell you why it's. I'm gonna tell you why it's a good book. Not only is it a good book, but the greatest book ever. Because ain't no other book, no ancient book at that, can actually describe in detail what can happen to a group of people, and what happens with certain events, even to this day. 2015, the Euphrates River officially had dried up. And according to Revelation chapter 16, verse 12, it said that the sun was poured out. I mean, not the sun. The sixth trumpet was poured out on the sun, and it caused the Euphrates River to dry up. That's what it said. And there's lots and lots of prophecies that actually prove, that the identification of the Bible. So yeah, it's a good book. It's not only just a good book, it's a great book.
This one from Coffee Converter says, Matthew and Tacori, in which other areas do you distrust mainstream science or expertise? Is it only all of astronomy, physics, etc.?
I think it's where the money is. The bigger the money, the bigger the deceptions. Where there's no money, there's probably not a lot of deceptions. But there's other things like
get paid?
like the science of like scuba diving. You gotta have the correct science of how to scuba dive or you will die. But for cosmology, you don't. You could believe anything you wanted to. People could say anything they wanted to. Governments could create any lie they wanted to. And unfortunately, they ran with certain lies that it disproves their theory. But they
Neil
have
Armstrong
to keep
would
running
have a
with it.
different opinion on that.
Can I just
that actor?
He's not an actor.
Movie. That was a cool movie. That was a cool movie when those guys, the movie where they went to the rock
Can I just
moon.
make a
Let's
point?
go to Dr.
That was a
Blitz.
great movie.
I think Dr. Blitz wants
Very funny.
Dr. Blitz wants to jump in.
There's this idea, and I don't fault anybody for having this idea. There's this idea that scientists make a lot of money, that there's a lot of money in science. Like, I want to let you know, I'm a working scientist. It's my day job. I make $3,500 a month. We don't do this for the money, right? We do it because we love learning about how the world works. And for what it's worth, I'm the kind of, I'm not a cosmologist. I'm what you might call a relativist. So I do general relativity. But like, We don't do this because the government is paying us big money. We do it because we're fascinated by how the world works. If we wanted to make money, we would have just gone into finance with our PhDs and made $400K a year. That's just not how we do it.
Yeah. So, but if you had the opportunity to make more money, would you take it?
No.
Okay. Yeah.
That's
so
what he
you're
just
maybe-
said.
Right. So, but you can admit that there's other people that maybe not as saintly as you.
No, they're all like this. No, like even
Right.
the top
You don't
professors.
represent every scientist, though. Just like I
know
don't
them.
represent
I know
every
them
flat
personally.
earther. You know, I don't
know them
represent every
personally.
flat earther. You don't represent every scientist.
Not
Blitz
every
is very
scientist, but
characteristic of many, many, many scientists that in this regard.
In fact,
Yeah, but
actually,
you're
I
unique.
can let
You're
me
unique.
let me give another useful piece of information. I'm currently applying for jobs because my position was temporary and it's running out soon. And on these job postings for professorships at universities, they post a salary. Depending on where you are, if you're in California, you might be lucky if you get at the very top end 150K. More average is you're looking at like 80, 85K for somebody with a PhD. So this is not bucket loads of money. Again, we could go work in finance
we can
and
talk
make way
about
more.
how much money is being circulated then. Let's talk about NASA's budget. Let's talk about that. And these other people also, it's like I can understand all these people have to believe certain things in order to make any money.
Well, it turns out it's really
So
expensive
if you
to
want
build
to make
rockets.
any money, if you want to
send
make
people to the
any
moon.
even minimum amount of money, you have to support the narrative of the flow of where the money is going to, such as like NASA. They
I
are
want to go to the next
highly
question.
motivated because of the amount of money. I'm sorry.
This one coming in from Wholesome Joe says, this one's on behalf of Destiny. Did dinosaurs exist on Earth? I think they mean like ever. I think everybody agrees yes, maybe.
Lovers?
I think Destiny asked that to Austin Whitsitt when they debated politics at some point on this channel.
Everybody agrees?
I am
got-
actually a young Earth creationist, and I have no idea why some flat earthers like Austin Whitsitt deny the existence of dinosaurs. We literally have their bones.
You know, that's
You know,
interesting. That's
Mexicano
cool.
NYC
That's cool.
says, flat earthers, when the sun goes down, why is it big? Why not small?
When the sun goes down, and it's sometimes similar to how the moon will look much bigger when it's closer to the horizon, which is also a perspective distortion effect. And when the moon and the sun are closest to my zenith point, they look smaller.
This one coming in from, do appreciate it, Wholesome Joe says, if electrostatic gravity is real, why do objects of different materials not get pulled at different velocities, like metal versus paper?
That's what I've been trying to tell.
Yeah, I think that's like a question you guys have to explain, not like that's kind of a Did you misunderstand, Tacori? That's suggesting that your claims are false about gravity and flat Earth.
Well, there's also the downward angle. So density still exists on all these things. So if things do have the charges of electromagnetism or electrostatics, density would not just disappear. Similar to how like gases, different types of gases have different molecular densities. Even the air will stack.
Do you believe in molecules?
I think we can get specific of that, but we are composed of something. We are composed of material that has properties. And we are physical, but the gases also have to obey density. Even though they float up, they're just stacked higher. And I use the term stacked.
Have y'all ever saw a molecule before, like with your actual
Yeah,
eyes?
we have literally pictures of atoms.
A literal picture?
There are literally pictures of atoms. Yeah.
The CGI picture or what?
Photographs.
CGI photographs or what?
No.
Because I just looked it up and they say they don't got no real. They say they ain't got no real image of an atom.
Okay.
You guys just use the word
CGI
CGI whenever you don't like whatever it is it's a picture of.
No,
this one from Double Down.
No, I just looked it up. That's why I say CGI.
Double Down says, Dr. Blitz, would you be willing to show them the sheet of the flat line that you zoom out and get their opinion on that?
Oh, yeah. Sure. 1 sec. Give me 2 seconds, okay?
Yeah, let's
in the
see
meantime, I'm going to give him a chance to load that up, and then I'll reread that same question. But even Lord said, what evidence do you need to change your mind?
Who's that directed to?
Yeah, let's do everybody. If everybody can do it in about, let's say you just gave it in even 10 seconds. If you said, hey, if I saw this, I changed my mind. Blah, 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 blah.
Well, one
I'd
thing
say
that comes to mind is the sun setting in Antarctica when Will Duffy and Austin and Jaron are going to be there.
You got it. Matthew, let's hear your response to the question.
Wait, could you
10
rephrase
seconds.
it again? I was laughing too much. I said, what is our what was
Tacori,
it again?
what's your answer to the question?
Shoot, man, in order for me to change my mind, the earth will actually have to be a globe.
I can't hear you, Tacori.
Now, I said in order for me to change my mind, the earth will actually have to be a globe for me to change my mind.
That's a good one.
Done.
You
What
change
else?
your mind about whether or not the planet is a globe if it was a globe. Matthew, what about you?
I would say if it actually was a globe, because at no height do we see the curvature.
Okay. Let's see. How about Dr. Blitz?
Oh yeah. I mean, the sunset would be pretty damning on the solstice. I do have that thing pulled up, by the way, so whenever you're ready.
You got it. Ready?
Yeah, let me show
And
my
that
screen.
question again was, this is for Dr. Blitz, they had said, would you be willing to show them the sheet of the flat line that you zoom out and get their opinion on that? I'm going to show that 1 second. And all right, now we can see it. Thanks, Dr. Blitz.
Right. So right now what we're looking at is one of these, I don't know if you can see what my marker, but this 4,000.1, that is about 500 feet from this red line. So, I mean, this red line's pretty flat. But if we zoom out, okay, so now this is, so each one mark is 1 mile. So the 4,001 is 1 mile away from this red line, which is the ground. Let's keep zooming out. It's still looking pretty flat, even 10 miles visible. 100 miles visible. It's starting to curve. Oh, and look, this is actually a globe, or rather, it's a hemisphere. So it's a scale issue, right? Or a skill issue, you might say.
Yeah, nice CGI, dude. Cool CGI.
This isn't CGI. It's a graphing calculator.
It demonstrates a concept.
Right, nice graphics.
It's a graphing calculator. I don't know what you want. It's just an idea.
All right, one at a time. Tacori, it's a little bit hard to hear you if you're able to draw closer to your mic.
Yeah, you hear me now?
Oh, it's better.
Yeah, we don't deny that perspective. We don't deny that things that's so small that it seems like it's flat, but then it would be clear. The thing is, you have to prove that that's what's going on in reality. And you have not, because your numbers don't match up, your amount of curvatures don't match up. I just debunked it with the X-15 hyperbolic jet, 67 miles up in the air, seeing in a perspective of 6,448 miles in perspective. So, yeah, that perspective is true, but that's not what's going on. Yeah. And not only just that, but that don't debunk flat Earth too, because we can zoom out on the flat surface too, and it'll still be flat. So that's not. I don't know what you're doing.
I wasn't providing that as proof of anything. Somebody just wanted me to show it. So
may I respond?
And they wanted us to get our perspective. Now, yeah, you can respond.
Who is that one to
respond?
respond?
Yeah, what I want to say is the reason your graph is slightly accurate, but more so inaccurate, is because you're trying to display curvature on like a picture. You're showing us a circle, but the theoretical globe Earth is not what is a 2D representation. On a 3D globe Earth, theoretical globe Earth, the problem is you have to notice you would be able to identify multiple locations. So on your graph, it's actually inaccurate because you're only showing one dimension of it. In reality, if the Earth was a ball, in every direction you'd be looking down, not looking at the side of an Earth like this.
You can do 3D graphs
like this.
You can do that. You can do a 3D graph. I just was using Desmos, which is two-dimensional.
Wrong. So that's how I showed you wrong, and how
I mean, it'd be the same thing.
Listen, this is how my real life video is proof, and your illustration is lacking. Okay, because I showed reality.
This one coming in from Wholesome Joe. Said Matthew or Tacori, please explain the specific steps of the scientific method and explain how you would go about proving flat Earth step by step.
First, what we'll have to do is we'll have to make a hypothesis. After that hypothesis, we have to test that hypothesis. After we do the experimentation, we have to test it and then test it over and over again to see if we get the same results. Then, then our view will no longer become a theory; it will become a scientific method. This is for anything, including flat Earth and globe Earth, both have to go through, which globe Earth has never went through at all. That's why they keep giving you not to scale models and numbers to prove their point.
Exactly.
This one from Hart Bender says, ask the flat earthers to explain how people see different stars and the skies rotate in opposite directions depending on the northern/southern hemisphere.
Okay, I did a demonstration about this. Oh, sorry, you want to go to Corey?
Yeah, I go. Yeah,
right.
It's due to the fact of not only our position on the earth, but also perspective also from out that position. You know, you could be in one perspective, and not only just that, but we got our own azimuthal dome perspective, where it'll cause our eyes and everything like that to cause an illusion, which give us different type of perspectives. There was an experiment that was actually done on this, that Whitson gets it, and a lot of other people actually done. But Globe Earth is just gonna deny it anyway, because they don't want flat earthers to have experimentation.
Gotcha. This one coming in from, do appreciate it, Wholesome Joe says, to Corey, what does CGI stand for?
Cake, greens, and ice cream. It stands for computer generated image.
You got it. Iris West says, question to Matthew, how do you explain the disappearance of a ship at the horizon level?
It gets far away. That's how it just gets so small. It's as things go further away, they look like they're smaller. And then it gets to a certain point where it vanishes.
I Killed Earl says, question for the Flirts, is the sun, if the sun is round and light is going in all directions and it moves in a flat plane, how can the sun ever set? You'd always see light, even faintly.
Well, the sun goes away, for one thing, and the sky itself can block light, as we've seen. And it just, like I said before, you have to also consider the inverse square law of light, that the further away a light is, the less powerful it will be, seemingly. And so that's the reason we cannot see the sun at night, because it's just too far away. And the sky itself. Okay.
Unfortunately, it doesn't check out. I mean, first, there's a law, and I don't remember what it's called, but essentially the surface brightness of an object never changes with distance, because the size of the object decreases also as the inverse square. So you have, the inverse square law applies to the amount of light received, but it's coming from a smaller source. And so the actual surface brightness stays the same. Secondly, what you're referring to is atmospheric extinction, which is the atmosphere blocking light. And I actually modeled this. I actually modeled what this would be like on a flat Earth. As the sun moves further and further away, even though atmospheric extinction does take effect, what this would appear to be, how this would appear to look, is that the sun would get linearly darker. So it would start off at maximum brightness directly over your head, and as it moves further and further away, after about 3 p.m. or so, its brightness would decrease linearly. But that's not what we see. It basically stays the same brightness until 30 minutes before sunset or so, and then it gets darker significantly faster.
Yeah, because it gets further away. Its path is taking it away from
everything I just said. That's fine.
No, I listened to it. I listened to what you said.
And didn't understand a word.
Of course not. You wouldn't. You're not able to.
No, I said you didn't understand a word of what he said.
Okay, whatever you say. I
This
disagree.
one, coming in from Fates, says the asteroid about to pass, where did it come from?
Rocks don't float. What the heck? Rocks don't freaking float. Whenever you ever seen a floating rock?
That's cool.
Y'all always talking about a space. Where you see a floating rocket in our reality? And number two, how can rocks pass in space where there's no, what they call it, when there's no drag or no thrust or no medium for it to travel?
Yes.
It needs a medium to travel. Where's the thrust? Where it gets its thrust from? It needs a medium. My head is hurting.
Oh no, I would say that.
These
I would say the same thing.
these are slow
Tacori,
questions.
can I say something about that? Okay,
Yeah.
this idea of asteroids, comets, whatever, space rocks flying around. The good question is, how does it leave the sun's gravity, enter the Earth's gravity, and then leave the Earth's gravity? And what is the propulsion system for an asteroid?
It doesn't. Everything inside the Earth and on the Earth and around the Earth is all inside the sun's gravity. The asteroid never leaves the sun's gravity.
So
We
it just
are inside the
decides to
sun's
come.
gravity
It
right now.
decides to come close to the moon, and then go away.
Yeah.
No, that's
So-
just
so-
the
well, no, it
orbital
does.
path.
It absolutely does. So what happens? It doesn't decide, but that's effectively what happens.
No, it does
Essentially,
decide.
No. I mean, it doesn't, but I can explain. So essentially, you have this thing that's orbiting the sun, and it happens to be, because of perturbations from Jupiter and Saturn, etc., that sometimes space rocks, asteroids, their orbit will intersect Earth's orbit. And as it gets close to the Earth's orbit, as the Earth and the asteroid get close to each other, the asteroid feels more of the Earth's gravity because it gets closer, the inverse square law. And so that'll change the trajectory of the orbiting asteroid, so that it'll hang out near the Earth for a month or two, and then it'll swing back out as it finishes its orbit around the Earth. That's a thing that happens.
So what you're describing is we don't see it in anything else. Only in this theory you're saying, which what you said requires a theory about Jupiter and other wandering stars. So your explanation requires another theory.
No, I mean, we can observe this happening like with telescopes.
No, that's a theory. Gravity is a
Just
theory.
pigeon
You're
chess.
assuming you're assuming things about wandering stars you call planets. You have to assume their mass, gravity, everything
You don't have
around.
to assume anything. You can calculate it. You can measure it.
This one
Yeah,
coming
so
in.
you took a scale to Jupiter and you weighed Jupiter on a
Scales
scale,
don't
and
measure mass.
you know definitively
Scales
how
don't
much
measure
it weighs.
mass.
It's a theory, dude. You're based on a theory.
Scales don't measure
explanation is
mass,
a
by the
theory.
way.
Wholesome Joe asks, how do different seasons in different regions work on a flat Earth? Also, heliocentric or geocentric for the flat earthers.
Look, I explained it earlier that there is the annual cyclical movement of the subsolar point from tropic to tropic. That's it.
Oh, can I address that, by the way? Just
They
as
also
a
asked
please.
if you're a
as a-
heliocentrist or a geocentrist, though.
well, they're neither. That's what I was getting at. I mean, geocentrism is a theory of the shape of it's not a theory of the shape of the Earth. It's a theory where you have a globe where the sun and the planets go around the globe. They're not geocentrists. If you ask the geocentrists 2,000 years ago, they would think that the Earth is a globe and that the sun goes around the Earth.
Matthew and Tacori. Same. That sounds good to you?
Was that a different question?
They asked two questions. It was just whether or not you're a geocentrist, as Dr. Blitz was talking about, or if you're a heliocentrist.
Well, it's celestial mechanics. It shows that the heavens are above the Earth, rotating above the Earth. And it all circulates around the North Pole, which Polaris is above the North Pole. So to say geocentric is not inaccurate at all. I like the term
even
flat Earth.
Eratosthenes was a geocentric. How you think you got
Yeah,
your
he wasn't a
so-called
flat earther.
curvature?
He wasn't a flat earther. He was a geocentrist. Geocentrism is a
Yeah,
globe Earth
but you-
theory about how the sun
Yeah.
moves around the globe.
No,
How the planets move around the globe.
that's why y'all accepted a globe and denied the geocentric because it's not a globe Earth theory.
Geocentrism is a globe Earth theory.
No, it's a flat Earth theory.
You can
This
just
one
Google
from-
this if you want. Just Google what geocentrism
No.
is. It'll tell you.
It's
This
just,
one
all
from
it
Fate.
says is all it says is that the
Everybody
Earth
who's
is in the
watching,
center
just
of the
Google
universe.
geocentrism. It'll tell you.
This
Yeah,
one from-
it'll tell you that it'll tell you that it just means the Earth in the center of the universe. But okay,
Fates says,
That's
say
all
the
it
sun
tells you.
has. Say the sun has gravity again. Love that slip up.
Who's that
No.
toward?
I think that was toward the flat Earth side, but I might be wrong.
I didn't say the sun has gravity. I use the example of a globe Earth and gravity not working because the Earth would be attracted to the sun and it's not. According to the globe model, the Earth is not attracted to the sun.
Wrong.
So why do
No,
they say
not
gravity
true.
is doing this? Because no, we're not attracted to it.
I
yeah,
mean, we
you
are.
just
In the
you
globe
just
model, we are.
strawmanned us. Thanks.
No, I didn't. The moon
Yeah,
is
you
not going towards the Earth. The
That's
Earth
not
is
what
not going
attracted
towards
means.
the sun. Actually, that's
Attracted.
what attracted does mean.
No.
The Earth is
No,
constantly accelerating toward the sun with its centripetal acceleration, just like Blitz was explaining when we were talking about orbits. You didn't listen or understand, apparently.
No, I listened. It's just I disagree.
You didn't understand.
You
attraction
say I
tells you
don't
that-
understand. I told you I
How fast?
disagree.
You demonstrate a lack of understanding when you
How
talk.
fast is
disagree
it
with you there, too.
accelerating towards the Earth? Yeah, how fast is it accelerating towards the Earth?
We could do the math. I think
I mean,
it's like
towards the
2
sun.
meters per second
Towards the
squared or
sun.
something like that.
2
Oh, the
meters. So
sun?
it's
How-
going towards. So it's
Wait,
going
are you
towards
asking
the
about
sun.
the Earth towards the sun? So again,
that's what you
acceleration,
s-
the direction of acceleration doesn't tell you the direction of motion, right?
But you saying
That's
it's
where I'm
going
from.
In order
towards
to
the
figure
sun,
out, in
right?
order to figure out the motion of an object, you have to integrate the acceleration, and that involves knowing the initial velocity.
This one from Middle East Witness says, for Matthew, what about Isaiah 40:22? It says, quote, "It is he who sits above the circle of the earth, and its inhabitants are like grasshoppers." And then they say, this looks like globe earth in the Bible, does it not?
A circle, like if I draw a circle, it's not a ball. A ball is mentioned in that same book of Isaiah. Like
Two-dimensional object.
God will take someone and throw them like a ball into a foreign land. That's a different language than someone sitting above a circle and the people look small. There's two different things. But I appreciate the biblical chat. But yeah, it's a circle is not a ball. A ball can look like a circle, but if I were to draw a circle and sit above it, it would not be a ball. Thank
So
you. That's it.
I'm a Christian glober. I love the Bible with all my heart, and I've read it 12 times. And personally, my view is that the Bible does not describe any cosmological model or take a position on the shape of the Earth. I have a video about this on my YouTube and TikTok.
Yeah, it actually said that the Earth is immovable. In the script.
Yes,
I think
exactly.
in the book of
It's
Isaiah.
phenomenological.
And not only just that, but it said that Jesus took Satan. Satan took Jesus and made him see all the kingdoms of the earth. How can
That
you
was a
see
vision.
all the kingdoms of the earth? How can you see all the kingdoms of the earth on a ball?
In a vision.
Yes, yes. And how Joshua prayed that the sun and the moon would stand still, and the sun and the moon stood still over locations that are mentioned. I don't remember the specific locations, but it says the sun and the moon stopped. And if the earth, okay, guys, what would happen if the earth stopped spinning according to globe model?
That was a
What would
miracle,
happen?
so God
What would
made it
happen?
safe.
But what would
And
happen?
it was phenomenologically described.
So what would happen if the earth stopped rotating? If the
God made it
theoretical-
safe by his miraculous power.
I
But
do
wait a
wanna
minute.
wrap
Not
up
bad.
pretty quick here.
But what would happen on a globe Earth? Not according to what would happen in God powers. Like what
Corey,
would
God
be
made
the
the globe, he
implications
made it
of the
safe.
Earth?
Pardon,
What would
Corey,
be
it's just
the
the background
implications?
noise is why I muted you. Which is also a good opportunity to wrap up though. This is not the end though, folks. If you want to learn more, you can click on the links of our guests. So if you're thirsty for more and you're like, oh, James, don't cut it off, I want more, check out our guest links. You won't regret it. Even if you disagree with them, there's a lot of value from hearing their ideas, their arguments straight from them rather than hearing what someone else says that they say. For example, if you're hearing from someone in your own camp, like, oh, well, they say this, and here's the response, it's like, well, it's great for you to examine firsthand what the opposite side says. So we do want to encourage you to click on their links. We do appreciate our guests as they are the lifeblood of the channel. Thank you guys for being with us. It's been a true pleasure to have you. I'm going to unmute you, Tacori. Pardon my unmuting you. It was just because of the background noise. But I want to say a huge thank you to our guests. It's been a true pleasure to have you, Matthew, Tacori, Dr. Blitz, and Peter.
Thank you.
It was a pleasure.
With that, stick around, folks. I'll be back in just a moment with a quick post-credit scene about upcoming debates. So stick around. I'll be back in about 27 seconds. Folks, want to say thanks so much for being here. It has been a true pleasure. Pardon that last super chat came in just as I went into the post-credit scene. So I do apologize, Ramen, for not getting to read that. So yeah, shoot me an email, Ramen, if you're concerned about that. Shoot me an email at moderndaydebate@gmail.com. And want to say though, thank you guys for being here. It's been a true pleasure. We're excited about the future. In fact, as if you maybe haven't seen, we're excited about this debate on the bottom right of your screen. Destiny versus John Doyle. Actually, just got covered up. Double Down, thanks for your super chat. Sorry that it didn't make it into the actual during the actual debate, but want to say, folks, highly encourage you. Check out the link in the description box. There are actually free tickets for this upcoming debate at Penn State. You don't want to miss it. Highly encourage you. Check out that link below as tickets are free if you get the standard ticket, and that's at Penn State. So if you're anywhere near Pennsylvania, you don't want to miss out on that. Do highly encourage you. Check that out. I'm going to be there personally moderating. It's very fun. It's going to be a lot of fun, and I hope to get to meet you in person there. But I want to say thank you guys for being with us. If you haven't yet, hit that subscribe button as we have many more debates coming up. In fact, including that one on the bottom right of your screen will be live streamed here at Modern Day Debate. You do not want to miss out on that. So hit that subscribe button right now, and we will see you at the next debate. Thanks, guys, and I appreciate it. It's been a good time. We'll see you at the next debate.